under the property that we have. Yes, David.
Sir, I would like to know if multiplication property is there and addition property is also included.
Multiplication property. Yes, for the multiplication property is there. Is there in the general property where we say that if we multiply a constant by a previous function, we evaluate to get the same notation.
Okay.
Yes, but then the addition is just within the various functions that we are given. So, for instance, if you take this function, for instance, here,
okay,
this particular function, for instance, please, this is 2 n raised to the power 2. So this 2 and this one are actually being added together.
Okay.
Yeah.
All right, sir.
Okay. All right, so now let's understand how we can analyze loops in our program. And please, in the program, have you gotten to loops yet? Your programming
Yes,
class.
sir. Yes, sir.
All right, then our job is going to be very easy here. So we have the loops, which is a programming structure which repeats a set of instructions until a condition is satisfied. And then when the condition is satisfied, the loops terminates and returns a result or whatever it is that you have written in the function. However, the loop's internal operations, how often it runs, and the structure, whether it is nested or a single loop, determines how effective the algorithm is. The loop internal operations, how many times does it run, and the structure, which is it a nested loop or just a single loop, determines how effective the algorithm is. And by this single loop or nested loop, those are the types of loops that we have. And when we talk about single loop, it does not have an outer loop. It's just one loop that we run within our program. And then when we talk about nested loop, it has a loop inside the body of an outer loop. So a loop within a loop is the outer loop, and then just a single loop happens to be a single loop, right? So if you know this, then it is very easy for us to analyze the various loops that we have in our algorithm. But then let me say this, as much as you can, avoid using so many loops in your program because these are very costly, especially when you are designing a new algorithm to do something else. So avoid loops as much as you can. All right. So now let's talk about how we can analyze a loop. And one of the complexities is the constant time complexity. And mostly we use big O of 1 to represent the constant time complexity of a loop. And this is the code implementation. And one thing you have to notice is that the differences lie between the various information that we have in here. That is the loop initializer, the expression, and then the increment operation. Richard.
Yeah. So with the types, we pointed at the single loop and nested loop. So both of those do while loop, then for loop and those ones. So what is the umbrella term for those ones? If the single and the nested becomes the type of loops.
So what is the programming lecturer say about those ones? did he or she talk about types of loop?
Yeah. So, but you know, the lesson has not concretized properly yet. So we have the fair idea about the types of loops. That
Okay.
is, I know about the single loop, the nested loop,
Yeah.
the do while loop, the for loop, but I just don't know the category under which those ones fall, as to whether the for loop and the do loop or do while loop are the main or the major types of loops, or the single and the nested are the major types of loop. That is what
Okay.
I want to understand here.
So we have the a single loop and a nested loop. Those are the types of loops. But we have variants of the loops. So those are what you just mentioned earlier. So the do while loop, the for loop, and the while loop are the variants of the loops that we have.
Thank you very much, sir.
Yeah. All right. So let's talk about this. The constant time complexity of an algorithm. And if it is a constant time operation, this is how we represent that big O of one. So you can be asked which of the following represent a constant time operation, and you should be able to choose the correct one. So let's look at the code representation for loop running C times. And as I was saying earlier, it is very important for you to pay attention to what is in here so that you can evaluate the loop more efficiently or effectively. So in that sense, I mean, you know all these one, the initializer, the condition, and then the increment operation. So in the condition, if the value is a constant, then obviously the loop is going to be a constant time operation, except that the loop is a nested loop. And if it is a single loop as we have like this, it's very important for you to notice the condition over here. If the value we are comparing with is a constant, then we could say that this is a constant time complexity of the loop. Please, are we clear?
Please go over it again, sir.
All right, so I'm saying that when you're given a single loop and asked to evaluate, it is very important for you to consider the various elements that are in here. And in your loop programming class, you learn loops. And you know, this is the initializer, this is the condition, and this is the increment operation, right? So I'm saying that with the condition, you have to notice the value which is equated to. Then you can determine if this is a constant time operation or some other ones that we might see later on. And this C here represents a constant time operation. And we have, so it is I is this less than or greater than is equal to C. And I'm saying that this C is a constant. So the C could be any value, maybe 200, it could be 300, it could be 400, it could be 1, it could be 2, it could be 3. So in that sense, since this is a constant value, then we can evaluate the loop and say that it is big O of 1, which is a constant time operation.
So
Are we,
your line breaks. Also. I don't know whether it's my side.
It was a general problem.
it's probably your side. Okay, so what I'm saying is that in this particular loop here, you notice the various elements that are inside the for loop, especially with the condition. So if the condition is equated to a constant, notice here that it is I less than or equal to C. So the C here is the constant that we are considering. And I said earlier that the C could be 200, it could be 300, it could be 400, it could be any number. So as soon as C is a constant, then we can evaluate the algorithm and see that, or the loop, and see that this loop has constant time operation, which is written as this. That is when C is equal to 20, or C is equal to 400, or C is equal to 1. Please, are we clear? So maybe in the exam or anywhere at all, we can ask you, can write this particular for loop here and ask you to determine whether this is a constant time operation or it is not. Abudu,
Sir, please, you mean, Rana, if I want to print 20, I'm sorry, to a console, the 20 is the constant, right?
yeah.
Okay, sir.
It doesn't mean it is going to print only the 20, but since the 20 are scalar values or constant values, then the time complexity of that particular for loop we are talking about here is constant.
Yes, sir.
All right. Please, any other question? All right. So we all
So
understand the
please,
constant.
please, sorry. So does it mean that anytime you see C in here, it stands for constant, or there can be another variable for that?
Yes, they can use A, B, C, D, E, F up to C. But you have to be looking if it is just a C, but nothing else. The C doesn't multiply any other value, but the C is just the C over there, or the A is just the A over there.
Okay.
All right.
Sir,
Hello.
hello, sir.
Yes, we can hear you.
Yes, the reason why, yes, the reason why I was asking is that, in a for or any other loop, when
Yeah.
you initialize, yes, for instance, for maybe int I is equal to 0,
Yeah.
I is less than or greater than maybe 100, then I plus plus, then you close it. Then you come to the body and write maybe print, or if it is C plus plus, C out, I am sorry. Then it will print, I am sorry, I am sorry. The number of times, if it is 20, it will print it 20 times. If it is 100, if the C is 100, it will print it 100 times. That's why I was
Yeah.
asking that.
No, it's not just about the output. It is about the value that is used here. Is it a constant?
Okay, so that means here we are not much concerned about the number of times it is going to print, but rather the constant or the
Yes.
time complexity.
Yes. That is
Okay.
why we have this C over here. Right, but mind you that even with this constant, if you have a nested loop and this is a constant, it is going to be different. The analysis is going to be different because it will run the constant once and the operation will continue from the second loop. Yeah, David.
So I remember from loops, we learned that whenever you're within a loop, you have to ensure that there is a certain limit as to when the loop will break. So are you trying to say that the constant is the limit that we set for the loop to break, or the limit within which the loop satisfies and then breaks?
So here the loop is running at a constant time and it
Yes.
terminates when I is greater than C.
All right.
Yes.
Okay. Okay. Thank you.
Yeah. Is any other question? All right, but so this simple loop is the big O of one, which is a constant time complexity. So let's move on to the next. So you have the linear time complexity as well. Richard.
Yes, sir. Sir, what from the programming class, what we got to know was that
Yeah.
if you know the number of times the loop is going to run, that is when you use the for loop. So does it mean each time we see the for loop, then it means we have to know that the constant time for the test statement, like for instance, I is less than or equal to C. That
Yeah.
one, once we see it like that, plain with the C not multiplying or adding any value, then it means we should understand that it is a constant time complexity.
Yes, but let me add this one over here. I don't know if you are seeing the screen, but we have a comment here like some big O of one expressions. So in as much as this will determine the constant time operation, what you put between the loop body also have effect on the entire loop. So it is not, Clifford, I'm coming. It is not just about this. That's what I'm saying. Just focus on this one alone. Don't talk about whatever that's going to be inside the loop body. Let's focus on these ones and then we get it clearly. So if this is a constant time, but then your loop does something different within the loop body, then the constant time complex is going to change from the constant times to some other ones that we are going to see very, very soon.
Understood, sir.
Yeah. Clifford, your hand was up.
So I wanted to give him some clarity, but you've touched on that.
Okay. All right. Thank you. All right. So let us look at this one here as well. And this is a linear time complexity, which has big O of n. Right. So we have the first for loop, and then we have the second for loop. Mind you, these are not nested loop. And then here, both loops are running n times and performing big O of one operation at each of the iterations. Please, are you following? Notice that the earlier one, we said that it is a constant. The C is a constant. But here, we don't know the number of times that these two loops are going to run. Therefore, we are representing them with an n. That's why we have the big O of n. So it means that both loops are going to run n times, and each of them performing big O operation of 1. Please, are we clear?
Yes, sir.
All right.
So
And we
please,
can, okay.
so please. So the n means there is a number.
Yes, there's a number which is unknown for us. But
Okay,
a
let's put
constant
a
here
number
means
there and see what happens.
we should put the number there and see what happens.
Yes, put a number
So,
there and let's see the outcome. I don't know. Yeah.
so if you remember from the previous lesson, we said you have two ways to analyze an algorithm. The first one is the experimental, and the other one is I've forgotten the name. So the experimental deals with the real data. However, if we want to evaluate the algorithm independent of the various hardware characteristics, that is when we use the other one. What's the name?
Asymptotic.
Asymptotic
Asymptotic.
analysis. So this is the asymptotic analysis we are doing. If you put a number there, it is going to run. It's going to be a constant, all right. It's going to give us a constant time operation. But then it means that we don't have to move further and use the experimental analysis to evaluate the algorithm. In that sense, we have to go back and talk about the various hardware characteristics. And here we are not using the real data. We are using the asymptotic analysis to do that. Festus.
Okay, so I think the concern here is that with this one,
Okay.
just as you said with the constant complexity,
Yeah.
with that one, here we can use any variable to represent. So if we are to bring that definition here, then it means N2 is any variable, and how to know that this is a constant or uh, linear time complexity will be quite complicated, because we use C here, and I can choose to use, maybe with a constant, I can choose to use the same N, just as
Yeah,
we
but
use
you need to define it as a constant. That is what we have where I is greater than C and C is a constant.
Okay, so the definition will help when you define it, that is where it will help
Yes,
know
obviously,
that exactly this one is
yes. So
okay.
obviously
Thank
the variable should be defined. The C here is a
Okay.
constant. And as one of you said that the moment you use a for loop means you know the number of times the algorithm will run. So if it is 6, that means the C is going to be a 6. But in some instances, you wouldn't know. So you can represent that with just an N, which is going to run N times,
Okay.
which is a theoretical evaluation of the algorithm, but not empirical. That is why we didn't add the value as maybe 20 or 200 in this particular one. We just use a C and noted it as a constant. Festus.
So you say it is the order.
Okay, Eric. Eric, you haven't spoken since last 4 weeks. Talk to us.
Say I don't know whether I'm confusing myself. I thought with a constant time, I heard you say something like that variable there we mostly use you said something like from A to F or so. You mentioned some letters that are used.
A to C.
Yeah.
Yeah, A to C,
A to
something like
Z.
that.
I meant A
So
to Z.
Z.
A, B, C, D up to Z.
Oh, okay.
Yeah. But you
Okay.
need to
I thought
define
I
the
had,
variable as a constant.
okay.
Yeah.
All right, sir.
So
Thank you.
if you look at the top here, we say here C is a constant. That is, we predetermine or know that it's going to run maybe 6 or 4 times. Then we can evaluate this as constant time operation or constant time complexity. So when you write a function like this and you leave it open without telling us C is a constant, then everybody will also evaluate it as this.
So, sir, please, does it mean that in an exam they will
Okay.
write where C is a constant or where C is positive integer or whatever? Are they
Yeah.
going to write it in that?
Yes, that is if we give you the code like this and ask you to tell us which complexity is it, then we have to define and tell that C is a constant. However, if we ask you to write a for loop to which has a constant time complexity, then when you write it for us, you need to tell us that C is a constant.
Okay, so
All right. And then here basically means that our for loop is going to run n times. Both loops are going to run n times, and then performing big O operations that we have. So please, who can give us some examples of the big O operations? A constant time operation. Anybody? I think we did that last week. I remember.
Sir, sir,
Yeah, listening.
with a linear time complexity,
Okay.
here there is C being the positive integer, which is constant.
Yeah.
But in the this thing, you've written n, and you are saying that n is a constant, so it's a bit confusing. If you can clarify that for me.
I'm not saying n is a constant. Or did I say n is a constant?
You said
So
you
this
said
particular line here,
uh
please can I come again? I don't remember saying n is a constant.
yeah, you didn't say n is a constant, right? Yeah,
Yeah.
but I'm seeing n here. You said n is the nth something
N time, the loop run n times.
time. Okay.
Yeah. But then this is an error this is supposed to be in the previous slide, but not here. Because I believe if you look at both for loops, there's no C in there. It is just N. And N is more or less an unknown value. Please, are we clear? Yeah, so back to my question. Some
Yeah,
examples,
sir.
Richard.
Sir, please, as you were clarifying his doubt for him, I also came across mine from there. I think I
Okay.
also wrote it as part of my note too, that
No, no, please
where
just
C
cancel
is a
this.
positive integer constant.
No, please cancel this.
Ah, okay, okay.
If you wrote
So
it,
what should we place there instead of?
nothing is supposed to be there because you don't know N.
Okay, okay, sir.
Yes.
Thank you.
Bismarck.
So please, where is the declaration? Where do we declare it? Like with the linear time complexity.
Where do you declare what?
Yeah, I want to know the declaration. You said you should declare it. Like, so if you declare it, then you know the type of loop that you are running. So I just want to know the declaration.
If you look at it down here, if you look at down here, you have here both loops are running n times. So the n times here means that we don't know how often or how many times the loop is running.
Okay, sir. Okay, sir. Thank you.
Is there any question? Yeah, so back to my question again. Someone should give us some example of a constant time operation. And you know operations already. Nobody. All right, so let's go and find it out. All right, so let's talk about the quadratic time.
Sir, please, you give another one. In fact, we can't. You said we should go and find another one. We are not getting this one.
I'm not talking, you don't get this.
The way I'm struggling here. It's serious.
Why don't you understand? What I said is different from what we just did, though. The question I'm asking is different from this, but we did it last week.
So let's proceed.
Abudu.
So now between the constant and the linear time complexity, I don't know if I don't have eyes. I can't see the difference between the linear and the constant time complexity.
Okay, so let's do this. For the start, let's look at this one over here. For int I is equal to 1, right? I is greater than or equal to C, I plus plus. I hope we get that.
Yes, sir, that one.
This is clear for everybody. All right, so let's look at the second for loop in the linear time complexity. Int I is equal to n. I greater than zero and I minus minus. So earlier on in the previous one, we said I is equal to 1. Right?
Yes,
And
sir.
then,
Yes, sir.
and then we are saying int I is equal to n. Let's look at this particular one over here as well. Int I is equal to 1 and I is greater than or equal to n. I plus plus. So what I'm saying is that less than or equal to n. And what I'm saying, is that in the definition of the previous one, we're very certain with the C, and we say the C is a constant. That is, we know the C already before the computer starts running. That is why the C is a constant here.
But for the linear, we don't know.
We don't know how many times it's going to run.
But you are just.
So we're just using the n to
Okay, but
represent.
Sir, in the programming class too, the master told us that, or in the notes, even in the notes, they said that before you use for loop, that means you know the number of times you are going to run your program is going to be run. If you don't know, you use the while loop or do while loop. That's why my mind has been psyched that whenever you are going to.
Yes, so in a way that is true, but in some cases the value of our condition changes as the computer runs or the code is being run.
Okay, sir.
Yeah, so that is why the earlier one is a constant time operation. That we know how many times the code is going to run. However, in this one over here, we don't know how many times this particular for loop is going to run. Neither do we know how many times this one is going to run.
Okay, sir.
Please, are we clear? I'm just trying to find a real example. David.
Yes, sir. Sir, I believe that the confusion is in the first one you just presented, because they are all similar. Comparing it to the constant. No, I'm not talking about. I'm still on the linear. When you look at the representation of the linear, the first part to that of the constant, they are almost the same. The only thing is that you have used C and N to represent the two. And if you come down, they say the big O expression is that big O of what? Of 1.
Yeah.
And the same thing is also in the constant. So this brings the confusion. With the second one, where we know that the integer is an unknown value or an unknown number, but we are expecting that the integer is greater than 1. So meaning that the loop will run until maybe it will stop whenever the integer gets to 0.
Okay.
And you could see that even here it's clear that the integer is supposed to be reducing. So whenever it's being run and it's continuing from a certain level or whatever number of times, but whenever it reaches 0, it has to break. But with
Yeah.
the first one, the constant is the same as the n, and that is making us more confused. So I don't know if you can, if that the first part is not part of the linear complexity, linear time complexity, you can get that one out so that we can focus on the second one, which is making the whole thing more clearer. Thank you, sir.
Both loops are part of the linear time complexity. Maybe you are making things complicated. Let's get it right here. So we said earlier that for experimental analysis, we use real values to evaluate the algorithm, right? However, with the asymptotic analysis, we cannot use or we don't use real values. That is why in this instance here, let me clean. In this instance, the C is a C, because if we use a value here, then it means that we are evaluating using the experimental analysis. And that is not the case here. So anywhere you see in this particular place a C, then the C is a constant, which it could be a scalar value, 1 up to infinity. As we pre-know that this is the value that we need to replace the C. So C can be 30, can be 40, can be 60, can be any value. But since we are not doing the experimental analysis, but we're doing the asymptotic analysis, we have to use a variable to represent our constant. And here we are choosing the C. So that we can do the asymptotic analysis. Please, are we clear? Are we clear with this one? All right. So let's
Yes.
go to where the confusion is. Still bear in mind the same asymptotic analysis, not experimental analysis. But then we have these two loops. We don't know how often they are going to run, because in a way, some of the input does not depend on our hard-coded algorithm. In some cases, when you write a program, you depend on some other inputs so that your program will run. In that instance, you wouldn't know the number of times the code is going to run. I don't know if you get what I'm saying. So in that instance, because you are relying on some information from other places to support your program to run, then it is appropriate for us to use N. That means the number of information that will come from the third party will not give us the N for us to run on, or to run the N number of times that we have. Abudu, I'm just trying to find a real world example.
Sir,
Okay.
sir. Yeah, I've also read something, and then they say that the constant time complexity takes the same time regardless of the input size, whereas the linear time complexity grows linearly with input size. So that means the linear time complexity, as the input
Yeah.
size increases, it grows linearly. But that of the constant, whether you increase it or you decrease it, it grows constant. It doesn't add up. The time complexity doesn't add up. It stays constant.
Exactly. So that is what I was explaining, that in some cases, your for loop will run based on some information or input from some other places. And you don't have the pre-knowledge of those information that are coming in. So it is best for you to define the algorithm to run n times. And the n times means that the number of information that will come from the external to add up to yours will give you the number of times the algorithm or the for loop will run.
Okay, just like mathematics, when you are to substitute maybe f of x, where f of x is 5, that means at the end of the day, your answer or your output will change. Whereas the constant value of the function is still the same. It doesn't go anywhere. For instance, if your constant has been given as 5, when after the program has run, it will still be 5, right?
Yeah. So let's take this example for instance. So this is going to be the constant time operation, right? But the linear will be something like this. And we can get the input size to be, this is 2, this is 3, this is 4, this is 5, this is 6, right? So that this is the constant time and this is the linear. So even if the input size, as Abudi said, is 2, the same we have, doesn't increase. When it's 5, the same. When it's 6, the same. However, for the linear, if it is 3, it increases the complexity. The same applies to 4, the same applies to 5, and then the same applies to 6.
Okay.
So
And then when it is
means that
decreasing to hello, sir.
and the
Hello, sir.
So your end is breaking, so if you can reposition yourself for a sec.
hello, can you hear me?
Yes.
Yes, sir.
Any question on the? All right, Eric.
Hello, sir. Please, I can see we are looking at linear time complexity, which is big O of n. But
Yeah.
under the for loop, that expression, I still see some big O of 1 expressions, and I'm getting confused.
Yeah, so even if you have some big O1 expressions, this one will determine the upper bound of the algorithm, because this is quite less compared to this. And as I said earlier, previously, I said that we use the big O notation in the upper bound of the algorithm. So these ones are going to determine the upper bound of the algorithm. Because big O of n is quite higher compared to the constant time.
So, sir, then the note is a little bit misleading, because if you are to have big O of n, why do you have big O of 1 in the note?
No. It is not. It's not confusion. I mean, in the for loop process, you can have expressions that are big O of 1 notations, expressions that are big O of n notations. There are any of them in there. So the note is not misleading. That is why I asked that, can you give me examples of operations that are big O of 1 notation? And then nobody answered the question. So you can have in the for loop body, you can have some operations that are big O of 1 expressions, others that are big O of n, and so many others. So it's not misleading, please. Eric.
Yeah, say.
All right.
Say.
Yeah, we are listening.
Please, I was also thinking that the symbol O of n as a complexity defined the linear. So does it mean in the under the linear time complexity for the loop, for the for loop, we can use the O of 1, which is the constant one there. Like look at the loop body, the comment where you wrote the at the body
Yeah.
section. Yes.
Okay.
So the O of 1. There, initially we got to know that one was for a constant, but the
Yeah.
complexity for the linear is the O of
Big O.
n,
Yeah.
big O of n. Yes, sir.
Yeah.
But looking at the O of 1 appearing under the linear complexity, that's what I was also looking at. I thought it was a mistake there, though.
No, it's not a mistake. So what I'm saying is that I don't know if you've done extensively with the for loops, but when you write a for loop in the loop body, you can have expressions that have big O of 1 notation. You can have expressions that have big O of n notations. So this is just to show you that in the loop body, you can have expressions even big O of 1 notations. But yet still, this particular for loop is evaluated as big O of n. Please, are we clear?
Yes, sir.
So please, the note is not misleading. So you can give us some examples of some big O of 1 expressions. Eric.
Sir, sorry, the previous hand.
I thought you wanted to answer the question. So please, the expressions are different from this one here. So we're evaluating the entire for loop. That is why we have the big O of n. But these expressions are the various operations that we can write within the loop body. So some examples could be that we want to add the number at the second index to the number at the third index. Those are some of the operations, and they have big O of 1 operation. When you evaluate that particular operation in the for loop, it is big O of 1. That is the constant time. Because if you want to access the element in an array, you only need a scalar value or a constant value, which is the position of the element, and then you get the various element in it. Please, are we clear? Mavis, are you here?
Yes, sir. Please, I'm here.
Is everything fine?
Sir, it's not fine at all. It's not fine at all.
That is not fine. Why don't you understand?
Sir, you know easy. Man, the hala.
Achampo, you just came to say something and left. Why is not fine?
Sir, confusion. Oh.
Where from the confusion?
The whole show.
David.
Hey, how can you say the whole show?
Sir,
In fact, the whole show, sir, we are totally confused. For instance, sir,
Let's
some of
call
them
it
are even.
we should not pretend. No.
We shouldn't pretend.
Hold on.
If they are to drop this in an examination, we are all going to suffer.
Please.
David, hold on. All of you should hold on.
Yes, madam.
Wait, what do you mean by the whole show?
Madam, I said the whole show. The whole show simple means you are totally confused of the whole thing.
So why is it that during the genesis of the explanation, if you are not getting something, you did not prompt him, and then you wait for him to get to where he is, and then you are coming to say the whole show?
The thing was that when we started, we were getting the whole idea. But at the latter part, everything has become unified.
So let me come in. So the whole show,
yes,
when he started, we were getting it. So it means at a point, that is where the confusion started. So if you can pinpoint the exact point, but you don't say the whole show, I believe most of you are teachers, and you know how it is when your students tell you the whole show. So I believe it goes to
Yes,
a point
madam.
that is when the confusion started. So if you can pinpoint that particular point, but if you say the whole show, then it means more than 1 hour that he has been talking. It's like he was talking to the air or something. Let me put it that way. So if you can be specific, maybe
Oh,
this place
madam, it's
for
not
the
like
full
that.
loop, it iterates, we cannot get
It's
it
not like
for
that.
this linear whatever I'm not getting here. But if you say the whole show there, you are not being fair to us. So if you can come with specifics, then he will use those specifics to address your concerns. I hope I've made myself clear. So come with your specifics. What
Yes,
don't you
madam.
understand? Maybe from the whole loop section, maybe the linear something I'm not getting. Maybe this, how did we get to this place? It's better, but if you say the whole show, hey.
Madam, the thing
The
is,
whole issue is that the thing is that this was treated under,
Madam,
I
this is
think, programming.
everybody is zero.
And then when he said started, he did very well by going according to what we learned under programming. But somewhere along the line, it has deviated the course, and then it is even contradicting
No.
with
You
what
need
the programming teacher said.
you need to choose
He
your
was
words right.
doing so well. He has deviated. What do you mean by he has deviated?
Programming is
He has
different
that he
from
deviate.
algorithm. So
Doc,
how does he
Doc,
deviate?
Doc,
Those are
Doc,
the
I
words
didn't
that
say he has
those
deviated.
are
I
the
said,
words that you are using. So choose your words rightly.
oh, Doc, I said that some places were contradicting with what we learned under programming. So, Doc, we say if you could kindly, start over, so that we will get the point by point. If not that,
Start
Doc,
over from where? Start over from where? Specifically, start over from where?
Doc,
madam, the thing is
start from the
constant
beginning.
and complete in the beginning. Madam, is the
Beginning.
constant in the
Well, hello.
Yeah, yeah, Bram.
Madam, I think the problem is
David.
the difference between the constant time complexity and the linear time complexity. That is where the issue have
Yes,
Yes, if you
exactly.
say this, it's
Exactly.
fine. But if you tell him that
David,
he should start from the beginning, then it is not good.
David,
Then it is not good.
hello.
Yeah.
David.
Clifford, yeah.
You see, though we learned about
Hello, David.
loops in programming, but this is algorithms. And you see, from the way you are speaking, you have already psyched your mind that the course is difficult. There's no course that is actually easy or difficult. It's all about mindset. So as a person is teaching, you have already, and what you learned in our programming is not wrong. What is in programming, for instance, we haven't learned anything about constant time and then linear time. So you need to sometimes try to learn in addition to what you have already learned. You don't do comparison. When you say he has deviated, it doesn't augur well. He's also a human being, and as a teacher, if you are teaching and your teacher tells you that,
Clifford, I didn't say he has
That
deviated.
is the
said
I
it.
word
said
We all
some
heard it.
parts are
that is the word
contradicting.
that you use.
You use
Oh,
the word
brother,
deviated.
you
We all heard it.
so
Doc,
kindly apologize.
pardon my word. Pardon my word.
Okay.
It was
So
not deliberate to
let's
use.
settle this. Let's settle this. Now we have gotten to know where the problem is: the constant complexity, and then the time. Is it time linear complexity zone?
Linear, yes.
So we will take that aspect again, but we cannot start from the whole show. I need to be frank with you. And
Sure,
one thing
sure.
that you need to know is that in programming and in computer science, the person talking should keep quiet and listen to me. In computing, we do transfer of knowledge. We do transfer of knowledge.
All right, hello. Can you hear me?
Yes, sir.
Yes, sir. Yes, sir, we can.
Oh, sorry, I've
Yes, sir,
been
we can hear
talking,
you.
not knowing that I'm muted. Sorry. So I
Oh,
was saying that now that we have been able to identify where the problem is, that is the constant and then linear complexity zone, we will take that one again. But one thing that you need to know is that in computer science, we do transfer of knowledge. You know, when you learn something, so on the normal, you should have even done algorithm before programming.
because almost everything on the computer science, the basics is algorithm. So if you get the algorithm concepts right, then based on that concept, you can go ahead and then
Doc has muted herself again.
Please, can you hear me?
Yes, sir.
hello.
All right.
Hello.
Hello,
Can
Doc.
you hear me? Yes. So what I'm
Yes,
saying
we
is
can hear
that
you.
computer science is transfer of knowledge, and you should have done algorithm before programming. But it's rather unfortunate you are doing programming or you did programming before algorithm. But algorithm is the basics for almost all courses in computer science. So you need to try and understand these concepts. And in the course or in your progression in the studies, you get to know that these are the things that you are learning in algorithm, and so you transfer that knowledge to other courses. So please, we will take the constant complexity and then the linear complexity aspect again, but we cannot start from the beginning. That one I need to be very honest with you. And if we go over and then you don't get it, then we will recommend that you get the video and then you watch it again. There are lots of resources on the internet as well. So you can get some videos on the topic and then watch. But as it stands, we will take those two aspects again. I would need you to pay much attention. And if you have any question, you should be specific as possible. Don't come and tell us the whole show. You are teachers and you know how even that sentence, the whole show even gets people irritated. You should come with specific questions. We need specific questions. So if maybe where the for loop is the iteration, I don't understand why this became one. Then we can handle it. But if you tell us the whole show of no, I don't think you'll be fair to us. So please, very kindly take the complexity aspect again, the linear and then the constant aspect again. And then if so, I believe some of you understand what he has done so far. If so they don't get it, then perhaps we'll get one person who has gotten the concept. We will organize an online 1 hour class in the course of the week. Then the person can take them through again after they have watched the video. Or maybe there can be small group studies and then they can get to understand it. But as it stands now, we will take it again. So please, I need you to pay much attention. And then if you have questions, you should be specific as possible, not the whole show, please. Is
All
that
right,
clear?
Doc. Yes, sir. Yes, Doc. Doc, please, thank you very much. But before you go, please, can you help us with the areas of the quiz and the exams as well? Thank you.
What is being taught to cry? You don't understand. I've not gone. I'm still on the call. I've been on the call. I was just listening to you. You people, the
Madam,
questions that some of you
Doc,
were asking. So I'm on the call. So Mr.
Doctor.
Derry, please take over.
Yeah,
Before we
Madam.
close, I'll come and I'll talk again before we close. So let's get the understanding of this first.
Yes,
Who knows?
Madam.
This is
Madam,
even
thank you
coming
very
in the
much.
quiz. Hello.
Madam, you bro.
Hey, yes, certificates na yes, we suffered. We were like you. We also so you have to do most of the personal studies on your own because of the nature of the program that you are doing. The time is very limited. Okay, so at times you need to take, if you want to be good in the field, you need to take an extra mile and then get some resources from the internet, and then so that you can be very good in what you teach the children. We all suffered. And those of us who were trained outside the country can imagine the pressure we went through. So it is very normal. So you need to, but nowadays the students, you want to be spoon-fed. You want 100% Cerelac, but we cannot do it that way. We give you small Cerelac and then you go and drink cocoa too small.
Oh, Doc, please, we understand you.
No. You are not white people to be eating Cerelac and Rita beans and conflicts. No, you need to eat Morocco. You need to eat yaka, all those things small. So please, we'll give to the white people's food, and then you also go and find the local food and add to it. All
Yes,
right,
Madam.
so there we
A black
can
man is still a black man.
We
All right,
really
thank you so
understand
much.
you. We really understand you. But
Therefore,
it is that the thing
But we do
pushing
understand you very well.
I'm not getting the practical aspect of the whole thing. So if you forget the
Hello,
verbal,
class.
hello. Can
Let's
we
let's
can,
Mr. Emmanuel
can we
continue.
organize
So
that?
let me tell you something. The videos of the classes that we have done so far is on the internet. I believe you have link to it. So after the class, that's why from the very first time I told you that after the class, try and find some time and then listen to the video. At times there are some things that the lecturer will say in the class, you might not, maybe something distracted you, so you will not get it. But if you sit down to listen to the video, you realize that, oh, no, even the lecturer said this and I did not even hear in the class. So you need to get some time and listen to the video again. You need to get some time and then listen to the video again. That is the ultimate thing. This thing that we are doing, they are recording it. And so after you get access to it, all my talking will come in the recording, but don't worry. You get access to it and then you listen to it again. That's why the very first class I told you, when you listen to it and then you have questions, you jot it down. The subsequent week you come with your question, we address the question. But I believe all of us are busy. If you are busy, then at the end of the day, you will not get anything from the monies that you are paying to acquire knowledge. It is not all about the certificate. It is not all about the paying of money. At times, you need to be equipped with that knowledge so that you know that the certificate that you are holding is worth it. Okay, people are buying certificates and all those things, but you need to exhibit that knowledge. You need to have that skills. So you shouldn't always think about, let me pay and then get the certificate and go. You should think about how you'll be impactful in the lives of others, how to acquire the knowledge to be impactful in the lives of others. Okay, Mr. Derry that you are seeing, he was my student, but he's still my student. Okay, he was my student from undergraduate through masters, and then he's about starting his PhD. He will still be my student. I was a supervisor. Okay, so it is constant learning, and a supervisor will get closer to his good students and then be able to work in a cooperative way with him. We have published papers, we have submitted some. I think he is not good. Would could give him this opportunity to also be on to teach you? No, and more the things on his own.
No,
So
Madam,
that is
please, you know
what
where we
I
are saying
want
he's
to
not good.
advise.
Madam, please. Madam, know where we are saying he's not good. We have made any
No,
such a comment.
don't get me wrong. The message I'm trying to send to you people is that you need to try and do self-studies. That is
Yes,
what I'm not
madam.
saying. Derry is no good. All that I'm saying is that because he exhibited that skills and knowledge, that is why Code took him on to impact that knowledge into you people. I'm not saying he's no good, or I'm not saying you people are saying he's no good. The message I want to send is that you need to commit some time into your studies so that it will not just be about paying the money, it will not just be about the certificate, but you can exhibit the skills and the knowledge that is worth the certificate. So no one has said anyone is no good or no. The message is that try to commit some time and then be impactful in the lives of others, especially the young ones that you are training. It is very, very important. All right, so there we take over.
All right, thank you so much, Doc. And I think we decided to go the practical way, or more or less the complex way. That is why there's so much confusion. Clifford, your hand is up.
Thank you, sir. I just want to share something small I do with my colleagues.
Yeah.
As we are doing this course, I know we all have various reasons or how we learn. Some might be learning just because of exams. Some are learning to actually know it for life so that they can practice it in real life. So me, what I do is sometimes it's not all the concepts that are taught that you may understand perfectly. So I can just decide to go on YouTube. I just want to learn about constant time complexity and then linear time complexity. There are several videos that can explain it. And as you keep doing that, you get a better understanding of it, because this course is very packed and we have time. Time is not on our side. So sir cannot take his time to be like going slow. At the end of the day, we'll not cover. It will be the same people complaining that we didn't finish the course material, and then we are going to write exam. So sometimes let's exercise patience and take the pain to do some of the researches on our own. That is what I personally do. I look for videos, and we also have several websites that you can do this kind of learning on your own to get a better understanding. So it's a plea, and then sharing what I do to some of my colleagues. Thank you.
All right, thank you so much. So as I was saying, I think we are doing more of the practical. That is why most of us don't get the concept. So please, the for loop on the screen, just forget about it. I'm going to read a text for you. I believe that will be easy for you to understand it fully. So basically, when we talk about the constant time complexity, it basically means that the algorithm running time, the running time of the algorithm does not depend on the input size. That is why I think Abudu made a comment that regardless of the input that's being given to the algorithm, the time is still the same. So, and I drew this simple diagram here where I wrote 2, 3, 4, and I drew a constant line like this. So regardless of the input that is being fed to the algorithm, the running time is still the same. That is what the constant time complexity basically means. So it doesn't depend on the input size to determine the complexity in terms of the time. I hope this English is fine. However, the opposite is true for the linear time complexity, where the algorithm running time depends on the number of times that it runs. And in the loop, we just use an n to represent the number of times these particular for loops are going to run. So if you don't want to go by the for loop and you want to write English, the English for constant time is that the time complexity doesn't matter the input size that you give to the algorithm. That is for the constant time operation. But then for the linear time complexity, the input size really matters a lot. And that is why I also drew this diagram to indicate that as the input size increases, then also the time complexity for the algorithm also increases. So this is 2, this is 4, this is 5. So as the input is 2, this is the algorithm running time. When it increases to 4, this is the running time. When it increases to 6 or 5, this is the running time. So to the X is going to be the input. And then to this part, which is the Y, is going to be the time complexity. David.
Okay, so I want to bring out how I understand it in simple English terms.
Okay.
Meaning with the complex time complexity, the time it takes for a loop to run remains the same no matter the input size. Even when the input size increases, it takes the same time to run.
Yes.
But linear time complexity, it's actually based on the quantum of input you put in.
Yeah.
The input, the larger the time or the longer the time it takes. So as you increase the input, it means it will take longer than the previous one.
Yeah. Yeah.
Okay, thank you. That is it.
I'm very happy that we all understand the English, but this is computer science. You might not be asked to explain it just like that. You might be asked to write more or less a simple code, a simple for loop to illustrate what you understand. And these are examples that we have given over here for the linear time complexity. And this is also another example for the constant time complexity. I believe this is clear.
Yes, sir. Yes, sir.
All right. And similarly, we have quadratic time complexity as well, which is n raised to the power c. And this is a code representation that we have. And these two are for loops, and one of them is inside another loop. So this is the first for loop, and this is the second for loop. However, the second one is inside the first one. And we learned earlier that this one ran n times. So obviously, if this one ran n times, then also the one inside is going to also run n times n times. That is, this one ran once, this will run twice. I hope we are clear. So to make this very easy for us, or to find the complexity of this particular loop, all we have to do is to add their various operations together, and then we use our normal annotation to determine the complexity. Michael Texan, where is the problem? Is it on the quadratic time complexity?
Yes, sir.
All right, so what I'm saying is that this is the for loop that we have. This is another that we have. Since this n is here, it means that we don't know how often this outer loop is going to run. And because it's an n, it means that it will run n times. But when this one runs once, the one within it is going to run twice. And that is why we have n times n.
Sir, please. Sir, so please, if we have the third one, it's going to be n times n times n. Is that it?
It depends on where it's located. So if it is between this inside this outer loop, then it is going to n, the outer loop will n, then this will be n times n, and the third one is going to be n times n as well. However, if the third one is inside the second one, then it is going to be n times n times n. Because when this one runs twice, the one within it is going to run 3 times, which is n times n times n. Abudu.
So that means when the execution starts, it will first run the outer loop once, then it will come down to the second one and run that one 2 times before it will go up.
Yes.
Okay, sir. Thank you, sir.
All right. So when we are done, we add the various operations, this and this. So we are going to get n plus. We're going to get n plus n raised to the power 2. And we learn the evaluation that we normally take the term which has highest impact on the algorithm, which is n raised to the power 2. So we have big O of n raised to the power 2. And that is what we say this is quadratic time complexity. So a loop within a loop is a quadratic time complexity. Christian.
Yes, sir. Thank you very much. Sir, please, the J.
Where's J? Okay, here.
I don't know. Is it that we just represent those letters, or there is that a meaning?
All right, so these are also variables that will hold some data. And in most cases, before we can use the for loop, it's more or less like we want to perform matrix operations. That we have matrix A, matrix B, and we are trying to perform an addition of those 2 matrices. That is when we use the for loop, the 2 for loop, one inside the other. So this I will take care of the first matrix that we have, let's assume is A, and this will also take care of the matrix B, so that we can now get each of their values and then add them together at the end when they run. Festus.
Okay, so please, does this mean that the quadratic time complexity only occurs when a loop is in another loop? That is, when the loop is a nested one, or it can also occur in that of the single loop.
It can't occur in a single loop. This is an example of the single loop that we have. This is an example of a single loop, and that is a linear time complexity.
Oh, okay.
Yeah.
I think. Thank you.
Is there any other question? And then also we have the logarithmic time complexity, which is big O of log n. So this happens if the loop variables are multiplied or divided by a constant. Kofi Owusu. All right, so before you can get a logarithmic time complexity, it means that the loop variable are multiplying or dividing a constant. So this is an example that we have. So the loop variable, which is the I, is multiplying by a constant C. Then when we evaluate the algorithm, we are going to get big O of log n. Similarly, if it is dividing, we are actually going to get the complexity to be big O of log n. So just notice that if the loop variable is multiplying a constant or it is dividing a constant, then we have a logarithmic time complexity. Please, are we clear? All right, so let's move on. So who can help us understand this? Anybody who can help us understand this particular loop over here? What will be the time complexity for this particular loop?
So I think this one will be a quadratic.
Why will it be a quadratic?
Because there is a constant here, sir.
What is a constant?
The variable is adding to a constant.
All right, anybody else?
Please kindly scroll back to the previous slide so that
this one,
not the logarithmic, the quadratic.
Okay, here.
Yeah, so for example, we said that for the integer I, it is equal to 1, and I is less than or equal to a certain number of times the loop will run. And then I is always added, right?
Okay.
It's incremented by 2.
Yeah.
So the 2 becomes a constant by which the I increases. And when you go the one you presented, you realize that you have been given a constant C, meaning that the I will continue to increase, or there will be an increment of I by that constant. So this shows that this expression is a quadratic time constant.
Complexity. Okay, Clifford.
Complexity, sorry.
All right, thank you, Clifford.
I just wanted to explain. Where we have the I plus is equal to C can be rewritten as I is equal to I plus C.
Yeah.
That makes it easier to understand for us.
Okay.
So
Yeah,
it will keep increasing by depending on the value of the variable C.
yeah.
So for example, like you're saying, if the I is increased by 2, and let's say we get I plus 2, then the next one will be I plus 2 again. So it means that the value we get for I will constantly be increased by the constant.
Clifford.
All right. So even aside that one, let's remember that we also have I is less than or equal to M. So depending on the value of M, the constant the value will keep increasing based on the value of the variable C. But when it gets to a number where that number is less than or equal to M, the operation stops from that end.
Yeah. So obviously this is going to be big O of M, because for this particular calculation here, whatever addition you do, you're going to get a constant or a scalar value. But then the loop will terminate if this condition is satisfied. I don't know if you get what I'm saying.
Yes, sir.
All right, so the complexity is going to be big O of M.
That is linear.
Yeah, that is a linear time complexity.
Yes.
All right. So who can help us get this one as well? I think we've just done this also. This is a for loop. We need another for loop. Festus.
So but it wasn't this, it was the earlier one. But if I'm to try this, I think this one is the quadratic time complexity, since we have a nested loop, and with this one we have the condition being n, so it will be big O of n square.
Okay. All right, so this is going to be big O of n squared, which is a quadratic time complexity. All right, so let's talk about recursive functions. And I believe we all know recursive, right? So when we talk about recursive functions, these are just processes in which a function calls itself directly or indirectly. That is what we call recursion. And the corresponding function is called the recursive function. So a function that basically calls itself is what we call the recursive function. And this is mostly used in what we call factorial. I believe we all know factorial. The math teachers over here.
Yes, sir.
So can you walk us through how the factorial is? I think after that, this will be clear for all of us. I don't want to go to this because some of us will be confused. So just talk to us in English terms. Factorial. Yes, we are listening.
So please, is the factorial coming from factors of numbers?
Is that factorial coming from?
Okay, so with the factorial.
For example, when we say factors of 12, we have 1, 2, 3, 4, 6, and 12. Is that what we are linking to this one?
Maybe this is
Jackson will help
factorial.
us understand. So maybe just listen to Jackson. Jackson, tell us.
So we have factors of a number, and then we have a factorial of a number.
Okay, yeah.
When we talk about the factors of a number, we are talking about the numbers that can divide a particular number. And then the factorial is the factorial sign is the exclamation mark. That is, that is bent down. So supposing we have 4 factorial, it means that the numbers that will multiply 4 below 4. So we have 4 times 3 times 2 times 1. That is 4 factorial. And then suppose we have 3 factorial, it will be 3 times 2 times 1. So the answer is that number is factorial.
Davis, are you clear?
Yes, sir.
All right, so that is one use case of a recursive function. So write the function that will call itself to perform the factorial for us. And this is an example pseudocode, which I'm afraid to go through it with you. But then in most cases, the factorial start from 0 and 1. Those are the base cases.
Very, let me take them through the code.
Okay.
Yes. So I need you all to look at your screen. So in the code that we have on the screen, that is the red highlighted area, we have integer factorial int 6. It means that we are trying to find the factorial of the integer 6. And from the explanation that he has given, or your colleague just mentioned, factorial means the number multiplied by 8 preceding in a decrement way. So for example, for 6, it will multiply by 5, 4, 3, 2, 1. But according to the factorial rule, any number less than or equal to 1, that is the base case, is that any number less than or equal to 1, the factorial of that number is 1. That is why we have if n is less than or equal to 1, return 1. So if we want to if we want to trace this code, then if what we are looking at is 6, so is 6 less than or equal to 1? No. So it means we'll go to the else section. So the else section is saying that we should return n, and our n is 6. David, please write 6 for me. 6 multiplied by factorial of n minus 1. So the n minus 1, our n was 6, so minus 1 will be 5. So we have 6 times factorial of n minus 1. No, don't write 5, just write factorial of n minus 1. And factorial of n minus 1 is 5 factorial. Please, are you following to this point?
Yes, Doc.
Yes, Doc.
Now, something, and we still have the factorial in there. So now our n, no. So it means we'll have to go to the else section. And the else section is saying that return n times factorial of n minus 1. So now it means that we will return 5 times factorial of n minus 1. That is 4 factorial. Is that one clear? So now we have 4 factorial. So we'll find the factorial of 4. 4 is not less than or equal to 1. So it means we'll go to the else section. So in the else section, we'll return 4 times 3 factorial. So there, please write 4 times 3 factorial for me. It's not plus, so it's times. The 6th side, it should be times. Times 3 factorial. So now our n is 3. Then we go through the loop again. So 3 is not less than or equal to 1. And so we have to go to the else section. So the else section says return n. Our n is 3. So we return 3 times factorial of 3 minus 1. That is 2. And so we still have 2 factorial. So we go through the iteration again. Is 2 less than or equal to 1? No. So we go to the else section. And it says return n times factorial minus 1. So we return 2 times 1 factorial. Now we go through our loop. Is 1 less than or equal to 1? That is yes. So it means that our base case has been met now. So we will just return 1 and then we will exit the loop. So at the end of the day, the factorial for 6 is 6 times 5 times 4 times 3 times 2 times 1. And then we'll get the answer for the code that we have on the screen. Is that clear?
Yes, Doc.
Any question?
Understood
So
perfect.
when we talk of recursion, it means the code would have to iterate till it gets to its base value, or it gets to a point where it cannot go on with the iteration, and then it will exit the loop. Is that clear?
Yes, please.
Yes,
All
Doc.
right, then take over.
All right, thank you so much, Doc. So these are some examples that we have for this one here, and then we have
Okay, let me complete this so that you take them. So for Fibonacci of 0 is 0. So Fibonacci also uses recursion. Fibonacci of 1 is 1. Fibonacci of 2, you go through the iteration, is 1. And the Fibonacci of 3 is 2 and others. So these are something that has been computed for you using a simple code. I don't know whether you have the code for the Fibonacci or so. Another confusion.
I have it.
Okay, let me see whether I can take them through that one. Yes.
You
So
have it. Everybody have it too. So take your time, please.
So this is the code for Fibonacci. The first one that we did is factorial. This is Fibonacci. And according to the Fibonacci rules, the base case is that if you have a Fibonacci of 0, the answer is 0. If you have the Fibonacci of 1, the answer is 1. But if it's neither 0 nor 1, so if n is not equal to 0, sorry, if n is equal to 0, it means you have to return 0. Else, if n is equal to 1, you return 1. Other than that, you would have to return the Fibonacci of n minus 1 times, I'm not even saying well, plus the Fibonacci of n minus 2. Is that one clear? This is very complicated, but let me come again.
Hello, Doc.
Yeah.
Please, oh, the Fibonacci, we don't know what it is, or it's the same as the factorial, or just a different name of the factorial. We don't know Fibonacci. Thank you.
So as we have factorial, we have Fibonacci as well. It's also a mathematical computation. Okay.
Okay.
So we
Okay.
try to write code to be so just like when you are doing multiplication of 3. You know that 3 times 1 is 3, 3 times 2 is. So that's the same way Fibonacci. If you have Fibonacci of 0, the answer is 0. If you have Fibonacci of 1, the answer is 1. If you have Fibonacci of 2, the answer is 1, like the previous slide. So we have to write code or algorithm for this Fibonacci series. So the series has been given to you in the previous slides. And how did we get this series? This is the code that they use in getting this series. The code states that, so this is a kind of algorithm for obtaining what we have on the previous slide. So if you have a Fibonacci of a number, if the number is equal to 0, then the code will return 0 because Fibonacci of 0 is 0. If the number is 1, then the code will return 1 because Fibonacci of 1 is also 1. But if the number is neither 1 nor 0, then you'll have to return the sum of Fibonacci of the number n minus 1 and then the Fibonacci of n minus 2. So for example, we are trying to find Fibonacci of 3. When we compare from the base case, our n is not 3. Our n is 3, so our n is not 0. So it means that the first case will not go there. The second case too will not go there because our n is 3. So it means we'll go to the next case, that's the else case. So we will return Fibonacci of 3 minus 1. that is 2, plus Fibonacci of 3 minus 2. There, can you write it for me? So Fibonacci of 3 minus 1. So we have the fib of 2 plus the fib of 1. There, are you there? Fib of 2. No, put the 2 first, yes, plus fib of 1. That is when we look at the L section. That is what we have now, because our N is what? 3. So we have fib of, they are saying that we should have fib of N minus 1 and then fib of N minus 2. And our fib of N minus 1 is fib 2. And our fib of N minus 2 is what? 1. So now, we don't know the fib of 2. So it means we have to go through the iteration again. So the 2 is not equal to 0. The 2 is not equal to 1. So it means that we would have to return fib of 2 minus 1. There, can you put it, maybe write an arrow up there and then put it for me from the fib 2. So we have fib of 2, which is equal to fib 1 plus fib of 2 minus 2 is what? Fib 0. So now, from our code, we know that, so we can substitute the values now. We know that fib of 0 is what? 0. So there we put 0 down. If you can take a red, no, use a red pen to do that one for me. And then we know that fib of 1 is what? 1. So put it down there. And then we go to the other side. Fib of 1 is what? 1. Because the fib of 2 is what we have expanded up there. So now we will add our 1 plus 0 plus 1. And then we'll get the answer to be what? 2. Yeah, so let's go to the previous slides and go and see whether fib of 3 is 2. You see, fib of 3 is what? 2. Okay, I was here.
Madam, please, from the pattern, I am trying to I understand it from the pattern's perspective before the code. And what I'm seeing is that, for instance, when we take from the 2, we can see that 1 was added to 0, and we had 1. Then from the range of 3, 1, those numbers below it, 1 was added to 1 to obtain 2. Then 3, 2 was added to 1. Then we obtained 3. Madam, please, are you getting my point?
Yes, so basically that is the Fibonacci series. So fib of 0 is 0, fib of 1 is 1. That is the base case. And then fib of 2 is 1. So to get fib of 3, it's fib of 1 . Hello. So to get the fib of the subsequent one, you add the last, I don't want to confuse you people, but let's stick to the code. But basically what he said was also right. That is the pattern. Okay. So fib of 3 is fib of 1 plus fib of 2. So 1 plus 1 will give you 2. So if you want the fib of 5, definitely it will be fib of 4 plus fib of 3. And then you get 2 plus 3 and it gives you 5. Fibonacci of 6 and 5. Fibonacci of 6 is Fibonacci of 5 plus Fibonacci of 4. That will give you 3 plus 5 and then it gives you 8. So that is the pattern. But if you are not following this pattern thing, then you can go according to the code that I explained. Is that clear?
Yes, madam. So please, madam, in an exams, if you are asked to find, let's say, Fibonacci of 8, you can just add Fibonacci of 6 and
So
7 to get your 8 straight away without going through the code given. Would that be okay?
So if it's in objective, then that one is fine. But if it's section B and then the marks allocated is 10, and then you write fib of 5, fib of 4, then you will get the mark. But if you look at the marks, you should be able to express it as maybe it will be fib of the way I expanded the code, then you get your full mark. So the marks will determine what you have to do. So you don't
Thank
expect
you,
that when
madam.
you write fib of 4 and fib of 3, it gives you fib 5. And then someone goes through the code to write fib 3, fib 2, using in a tree as the way I did for the coding. You get the same marks with the person. No. Is that clear?
Yes,
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 madam.
please.
Owusu, someone's hand is
Hello,
up.
madam.
Owusu. Yeah.
Yeah. Please, can you also use the triangle to deduce the Fibonacci numbers?
Which triangle is that?
The Fibonacci of 0 is 0. So under the 0, you write your 1. Fibonacci of 1 is 1. Under 1, you write 1 and write another 1. That is the Fibonacci of 2 is 2. Then
So
in
basically,
the sequential.
the base concept and the base explanation is how I've explained to you. And you know, in mathematics, people have a way of understanding or doing their computation. So not to get your colleagues confused, if your triangle thing works perfectly as the explanation I have given, then it's fine. That one you need to prove beyond reasonable doubt that you get those patterns. But if it doesn't work that way, then it means you can't adopt to the triangle thing. Is
Okay,
that clear?
madam. Okay.
Yeah. All right, there we take over.
Mr. Derek, your screen awful. Mr. Derek.
I think he's off.
Yes.
Maybe he'll come back. So as we wait for him, let me talk about. So basically, I learned you'll be writing 2 quizzes and then an exams. So the quizzes will basically be objectives. Let me put it that way. There will be objectives. And then for the exams, we'll have section A. For the exams, we'll have section A, which can be objectives or short answers. And then we have section B, which will do some computations for us. Some simple, but you need to think through it to get the right answer. So basically, that is it. The quizzes are objectives, MCQs. And then the exams, you write something for us. And everything will be from what we have learned in the class from the first week. So now.
Please, madam, your line was not stable.
So I'm saying that the section B, it can be short answers. Section C, A will be short answers, and then B will be some computation for us. And it will basically be what we have been doing in the class. So make sure you watch
Madam,
it.
short answers there. Madam, short answers the problem. Oh, make you do computation. Make you exhibit our skills.
That is
Fill
why
in
I'm
problem.
telling you that the section A will be short answers, but the section B will be computation, what we have done in class, the trees, yes. So
Wahala.
basically, that is how it's going to be.
Yes,
Madam,
But the quizzes will be MCQs. The quizzes will be multiple choice.
Madam, please, will Fibonacci also come?
I don't know. I
Oh.
have not set the questions yet, so I cannot tell.
Madam, please, the first quiz. Is it going to cover unit 1 and unit 2 only, or?
What? No.
The first quiz.
First quiz.
I said I've not even said the question, so I don't even know. All right, Derry, you can take over. I think your screen went off.
Thank you so much,
Someone's
Doc.
hand is up. Misty, Misty, your hand is
Madam,
up.
please, Madam, please. We know
Ma-
that PCC has a system it runs, said that for quiz 1, it covers maybe if you are doing 6 units, meaning it will cover unit 1, 2, and 3. So I don't know if you could clarify that for us so that we know our preparation towards the
But
quiz 1.
you
You
people
don't want
don't do units. You people don't do units 1, 2, and 3. Do you people? It is the regular. It is the distance people who do that. You
Madam,
just have 4 weeks. Is there anything unit 1, unit 2, unit 3 for you people?
Yes,
yeah,
madam.
madam.
Then that will be it.
All right. Thank you. The reason why I'm asking, Doc, please, the reason why I'm asking is that in the first block, we had some lectures in which we were told that the quiz 1 is going to cover only units 1, 2, and 3, and unfortunately for us to go and come across quizzes that covers the whole section. So we would like to be sure of what we are, how we are
Yeah,
supposed to
so
prepare.
you know, well, just learn to cover everything. Because when you learn to cover everything during the exams, all that you need to do is to do revisions and go and write your exams. Okay, so if the other lecturers said that, I'm saying that learn to cover everything for both the quizzes and the exams.
All right. Thank you.
Okay, there we take over.
All right, thank you, Doc. So basically, this is the last slide we have. And the previous ones, you will have to go and look for them yourself and try to understand them, which is the method that can be used to solve recursion. So one of them is substitution method, the recursive 3, and then the master method as well. But one of the most important thing is for us to understand why do we perform algorithm analysis? What is the significance in that? And some of these are efficiency optimization. We want to, in a way, manage the computer resources that we have, such as the CPU, time, memory, and storage as well. And one other important thing is for us to know which algorithm to select in a code that we are running. So if we're able to analyze the algorithm and know that this is better than the other, then in terms of the time and space complexity, then we'll be able to choose the right algorithm for a specific use case. So basically that is all for importance of analyzing algorithms, whether it is the experimental or is the asymptotic. These are the significance of analyzing algorithms. Any question? And I believe today is the last day, so you can ask any question that you want to.
Sir, please, if you would have time, I would suggest that next week is for practicals. You would probably take us through whatever we have done in the form of revision, please, if you would have time. Then, quite apart from that too, with what doctor explained to us, I got it correctly, but I want to also again follow it. Since I cannot add the results of Fibonacci 2 and 3 to get 4, please, now again, systematically, I want to take this again. If I'm given to find Fibonacci, let's say 13, please, if you can take me through, or if you can take us through again, so that I will see the step-by-step procedure to go through. Thank you, sir.
Let me come in. So basically, the step-by-step procedure that you go through is what I did for the 3. So the 3 is quite short. So if you want 13, it means you have to challenge yourself using what I've explained so far to see whether you get the answer
in the slides that have the answers. That is the Fib 1, Fib 2, Fib 3, Fib 4. So you just have to try your hands on it. We cannot spoon feed you every time, or we cannot spoon feed you every time. Okay, so we have done Fibonacci 3 for you. So maybe you challenge yourself with Fibonacci 5. After the computation, you check your answer to see whether it's the same as the one that we have on the slide. And then maybe you can do Fibonacci 10 to see whether you, because the answers have been provided for you. So if you are not getting the answer, it means you are not doing it well. So just for that will give you clearer understanding. But if we keep feeding you with all the information, then it means we are not helping you. We are not making you be good students. Okay, so we just give you the foundation, and then you have to build on the foundation to get a clearer understanding. So I will entreat you, I will encourage you that instead of going straight to 13, maybe you can try Fibonacci 6 to see whether you get the answer we have on the slide. And then you can go to 10 to see whether you get the answer. And then you can go to 13, the 13 that you are talking about.
Yes, Madam Doc, thank you so much. I really want to do it that way. But when he was writing it, I didn't get the values so well. It was cleared off. So that is my problem. I would love to
Can
do
we get the
everything up to the
video? Can we get the video? Maybe you can get the video and then.
All right, thank you.
Yes, so
Thank
that
you,
if you
Doc.
have any question, you can reach out to us. So maybe you get Fib 1, Fib 2, then it means you have to expand the greater one, that is the Fib 2. Then so just put an arrow and then expand, and then after you add the values and then you get your. It's unfortunate I don't have my PC. That is why I made him write on the screen, because I'm using my phone actually for the call. So if you check and then you don't understand anything, you just send me an email. Is that okay?
Doc,
Yes, please.
Doc,
Please,
please, I'm
who is the
suggesting that.
lady talking?
Doc, please, I'm Mavis.
Okay, so maybe if we have any challenge, just send me an email.
Yes, please. Thank you so much.
And the email, let me know that you are Mavis.
Yes, please.
From Switch Class. That is if you would have a question. All right.
Thank you so much.
Someone was talking to.
Doc, please, mine is just a suggestion. The latter part, the last subtopic, that the importance of analyzing algorithm. Doc, I think it's very examinable. So if you are to send a question, you kindly break it so that we will be able to write something. Thank you, Doc.
Are you the one to tell me the question to bring?
Doc, a suggestion, Doc.
You are a teacher. If your student tell you to bring this question, will you bring it? This is a university.
Doc, sometimes for
is a
the benefit of the adults, you know,
if
this is
even
adult
now,
education.
I will bring it because of what you just said, I will not even bring it.
Oh, Doc, very important. So that
Yes.
and those who will be able
It
to
is
write
not
something, will write
important. If
something.
it's very important to you, it's not me. I set my questions. So you cannot tell me what to include in the questions.
Oh, Doc, please, this was a suggestion so that those who are, you know, who cannot compute well will be able to write something small. Thank you.
Senior
Senior, what more?
Anyway, and I see that people are saying past questions. With the past questions, we don't have past questions. You have to
This
go
guy
to
all rush it too much. All rush it too much. One Russia could think.
I'm gonna say, yeah, when you crack and see a baby.
Hello, please. Maybe you were asking that we meet next week and try to maybe recap on what we just did. But unfortunately, even if we are supposed to meet, I wouldn't start from lecture 1 or anywhere. If you have a specific question, you bring it on board and then we try to answer it all together. But I cannot start from unit 1 to 4. But in the course of the week, if there will be time for me, I'll contact your course rep and then the message will be given to you.
Thank you so much, sir. Thank you.
Yeah, so it wouldn't be a must. It wouldn't be a must because
this course does not have that practical component. And of course, if we are to meet you next week, it means we are committing our own time. We will not be paid for that time. It means we are sacrificing our time to do that for you. So it cannot be the whole show. If you have specific questions, as he said, he would communicate to your course rep to see whether it will be possible or not. I
Thank
hope
you
it's
so
clear.
much.
So this is out of
Yes, ma'am.
sacrifice. Out of sacrifice. So maybe 1 hour or even less than 1 hour, then we are off. Or he will be off the call. That is if it becomes possible. All right.
Damn, you are
Is
so
there any
fantastic.
question? Any question before we end the session or the block?
Damn, baby, I is so.
Madam, please, is there other units like unit 5 and 6?
Charlie, you say one this one you have not even get it. Then when you are son of another unit. Hey, chairman.
Say, madam, say fancy.
Sometimes I don't understand.
Blood death.
I had no business a past question.
We
And you
need,
panel
we,
so
we
The
need,
manual is
we
there.
need,
Go and read the manual.
past question.
Let's have a decorum over here, please.
Yeah, yeah,
Okay,
hello.
Clifford.
See, the manual
Clifford,
is
your
there.
hand
If
is
you
up.
want more, if you want more session, go and read the manual.
Michael, someone is on the call. Someone wants to ask a question. So if you can let us hear Clifford.
Yes, ma'am.
Madam, thank you for the opportunity given. Actually, it's not a question, but I know we are all humans, and once humans interact, sometimes we do make mistakes. So on behalf of my colleagues and to you and then Mr. Derry, I want to say if in one way or the other any of our colleagues spoke in a manner that doesn't sound respectful, and please forgive us.
Especially to Mr. Derry.
Thank you.
Especially to Mr. Derry. Especially to Mr. Derry.
All right, that is okay. Derry, what do you have to say?
I wish them all the best. And hopefully next week we'll meet, maybe just for 2 hours or an hour.
All right. Thank you, sir. We are grateful.
All right. So if any question was so we want next week we want specific question. We don't want the whole show or the whole of unit 1, the whole of no, please. So make sure you watch all the videos and then write down your questions. If we come and then we realize that the class is not very effective, we will go off.
Okay, Doc,
So
well
if you
noted. Thank you very
realize
much.
that you have questions, send it ahead of time to your course rep so that by Friday the course rep will send it to Mr. Derry. If you have questions, jot it down and then send it to the course rep. Course rep compile the questions and then send it to Mr. Derry by Friday evening so that he will go through and then come and then take you through. Is that clear?
Yes, madam.
All right. Derry, is that okay?
Yeah, that's fine. That's fine, though.
All right. So we wish you all the best in your other block. Hopefully we'll meet in face-to-face sometime to come. Have a blessed Sunday then.
Much
Thank
return, madam.
you.
Bye-bye.
Bye.
Mr. Derry.
Derry,
Gone.
goodbye.
I wanted to tell him
Okra,
that he should share the slides for us as he used to do.
Humble lions.
Wow.
It is true you wanted to tell him, but he is God, so don't tell him.
But some of us, is it here that you ask the lecturer past question? And if the
it's
lecturer
very, that thing is very bad though.
It's very
Charlie,
bad.
we for check our manners. So
Then too, we tend to be humble lions afterwards.
because if the lecturer wants to repeat past question, you asking her past question, and one the guy on repeat past question.
I beg, it is so recorded. It is so recorded. It is so recorded. It is so recorded.
Pardon?
Please, let's log off and you can discuss anything you want to do on your own page. Thank you so much.
Don't be bad. We Bonabachi people. Bonabachi people are you?
Michael, please, sometimes the way you inject things like comments, if
I have never made any comment. I have never provoked anybody. Me sometimes I just make the class elaborate, not of any idea.
You see, imagine you are teaching your students, they are approaching exams, and then you give them past questions to that they should go and read. Indirectly, most of them will only focus on those past questions with the mindset that you are likely to repeat those things. So you don't ask your lecturer for those stuffs.
I have not asked such. It wasn't me, please.
Please, I didn't mention your name. Go to the comment section.
And Michael, I will say this. This is from that statement, the whole show. It's not fine. You're a teacher too. So please, let's be there.
I've withdrawn the statement. No more the whole show. I've withdrawn. Thank you, brothers.
You're welcome, bro.
Thank you. I've withdrawn.
You're welcome. You're welcome.
Thank you. But the humble lions among us, who tend to be Father Christmas too.
I beg. You guys, you are making noise. Christian Soglonu.
Your network is not working on.
Yeah. I mean, you know that I always come at the latter part of the lecture. So
I'm also trying to figure out the Fibonacci calculation.
You're asking how was the lectures?
Yes.
It was Fibonacci sum.
Clifford. Challenge me, I don't need to say anything, but I just follow you guys.
Bro, you see, these are things that we are not familiar with, so it's definitely not going to be easy.
Exactly.
It's definitely not going to be. But we just have to put up our best.
Oh yeah. God is in the boat. Don't worry. We shall sail through.
I'm trying to calculate whether if I can get the formula for the Fibonacci. I think I went to YouTube and they gave some almighty formula there.
No, you see that one, Christian.
Yeah.
It's the rule is that if the number given is either 1 or 0, so if it is 0, the operation will return 0. If it is 1, the operation will return 1. But if the number given is not 1 or 0, then that is where the calculation comes in. And the formula has been given n minus 1 and then plus n minus 2. So when you do that, the first one you have a fifth of that number. If maybe n minus 1 gives you 3. You see that 3 is still not 1 or 0.
Okay.
So you continue the operation on 3. That one to be 3 minus 1 plus 3 minus 2.
Okay.
For the first fifth, the second fifth, if that one is 1 or 0, you leave it there, then you continue with the other side. If not, you have to do for both sides. Then at the end of the day, all the fifth you did that you had the final answers to be 1, 0, you pick them and add all of them together. Then that will give you the answer that will be the final answer for that particular number, the Fibonacci of that particular number.
So let's imagine the Fibonacci of 3.
Yes.
So we do n minus 1 and n minus 2, right?
Yes.
So
where n is equal to 3.
3. So 3 minus 1 and 3 minus 2.
Yes.
So the answer will be 2 and 1.
So the answer will be fifth 2 and then fifth 1 plus fifth 1. You see that fifth 1, the answer is already 1.
Okay.
The fifth is Fibonacci, so Fibonacci of 1 is still 1.
Yes.
But Fibonacci of 2 is not 1 or 0, so you continue for 2. So you now have you proceed with n minus 1 plus n minus 2, where n now becomes the 2.
I beg you, let me, what is fig 2?
Yes.
What is the Fibonacci of 2?
Yes, so Fibonacci of 2 will be n minus 1 plus n minus 2, where n is 2.
Okay, so
So
we'll
you
do
have 2 minus 1, which will give you 1, 2 minus 2, which will give you 0. So you see that we now have 1, 0. Then you come and pick the other one. When you did the Fibonacci of 3, you had n minus 2, which you got 1. So that one you don't proceed again, you end it there.
Yes.
So you come and pick that one plus the 1 and 0 you got here. So 1 plus 0 plus 2 will give you 2. That is where Fibonacci of 3 is equal to 2.
This thing there. Charlie, let's start. So Fibonacci of 3. It will
Yes,
be
so Fibonacci of 3.
1 and n minus 2. So which is
Exactly.
3 minus 1 and
3
3
minus
2.
Yes.
Right?
So
Charlie,
the
can't
first
you share a screen? Can't you share a screen?
Okay, so let's try this. Let me share the screen and see.
Yes.
Christian.
Yeah, you can see my screen.
Yeah, so zoom it so that it will become bigger.
Big, okay, I will do it.
Zoom the work area.
Okay. Is it okay?
Yeah, it's okay. The text is clear now.
Okay, so we now have f of that is Fibonacci 3. That is what we are dealing with.
Yes.
Okay, so we have n minus
1. Put it in brackets.
Brackets, okay. Curly brackets, okay.
Plus.
Yeah, plus
brackets open. N minus 2. So the rule is that whenever you are given a number to find its Fibonacci, if the number is not 1 or 0, then you use this formula to calculate for it.
Okay, 3 minus 1.
Yes.
Sorry. Plus. Sorry. Yes, I was. So I'm hearing. 3 minus 2.
Yes.
So therefore, this one will give us.
So this one will be equal to no. Hold on. Cancel it. Clear it. Clear the 2.
Oh,
Christian.
So that is what I'm doing. Like this
no,
one.
The 2. Do F brackets open 2.
Okay.
So it will give you Fibonacci of 2 plus Fibonacci of 1. That will be the answer. The addition.
Okay.
Put F outside. The F to be outside. Good. Plus F of 1. Fibonacci of 1.
Okay.
Okay, so at this stage, you see that Fibonacci of 1 will give us 1.
Fibonacci of 1
will give us 1.
Okay.
But Fibonacci of 2 is not 1 or 0. 2 is not 1, it's not it's also 0. So we proceed with the 2. So we now find Fibonacci of 2. We already have our 1 here.
Okay, so we again go in
use
for
the n plus 1 minus n plus 2 to find the Fibonacci of n minus 1 plus n minus 2 to find the Fibonacci of 2.
2 minus 1. Sorry. Sorry. 2 minus 2, right?
You have 2 minus 1 plus 2 minus 2.
Yeah, 2 minus 1 and 2
minus
2
minus 2. So Christian, highlight the first F Fibonacci of 1 and change the color to red so that it will be easily understood. Change that one's color to red. Good. So now let's compute this one. So 2 minus 1 will give us 1, which will give us Fibonacci of 1.
Okay.
So F brackets open 1.
So this one will be give us F1, right?
Yes, F of Fibonacci of 1.
Okay.
Plus, so 2 minus 2 will give us 0. So we'll have plus Fibonacci of 2. The first one, you didn't put the plus there, or someone may not understand.
Yeah.
The plus in between.
Clifford, hold on.
Yeah, that plus there.
Clifford.
Okay. Yes.
Clifford.
Yeah, I'm listening. I'm responding.
Why bring the Fibonacci sign at the F2 plus F1 level? And why didn't you bring it at the 3 minus 1 plus 3 minus 2? Why?
No, that
why
one
didn't
is
you
a
bring
formula.
it from the beginning?
You see that we have
That
you
one
see Fibonacci of 3. Okay, Michael, get this concept
that
right.
is what we are calculating, right?
Yes.
The Fibonacci of 3 is what we are calculating, right?
Yes, all this is to find
And
the Fibonacci of 3.
Oh, okay. So we are finding the Fibonacci of 3.
Yes,
And
the rule is that
we
when
are
you are
using.
finding the Fibonacci of a number, if the number given to you is not 0 or 1, you use this formula n minus 1 plus n minus 2 to find it. And when you do the calculations and then the answers you get are still not either 0 or 1, you need to proceed with the one that is still more than 0 or 1. That's why we are proceeding to find the Fibonacci of 2. Do you get it?
So I'm getting it.
Okay.
I'm getting it.
Okay.
So if the Fibonacci of 0,
Fibonacci of 0 is 0, so we don't proceed.
So we don't proceed. It's just 0 straight away.
Yes. Fibonacci of 1 is 1. We don't proceed. But if
exactly
it is
what
not,
I'm trying to ask. So there is no formula. There is no formula for Fibonacci of 0 and Fibonacci of 1.
I don't get you.
So that means that there is no formula for finding Fibonacci of 0 and Fibonacci of 1.
N minus 1 will give you what?
You just said that. I am saying that. Hello, I am saying that. Finding Fibonacci of 0 is 0. Is that not it?
Yes.
And finding Fibonacci of 1 is 1. Is that not it?
Yes.
So assuming it comes in the exam, it means that there is no formula for finding either of them. You just go straight to pick the answer.
We were not given any formula for that. Yes.
Exactly. So apart from those two numbers, the others you are using this formula we are using right now to find it.
Exactly.
Thank you very much. Thank you.
All right.
So now,
yes.
That's
good, Christian. I like the coloring.
Yes.
Okay.
So where we are finding 3, that is 3.
Yes.
Here.
Yes. So through that, we got Fibonacci of 2 in the middle, which we have to also continue to complete it.
Exactly.
All right. So we now have Fibonacci of 1 plus Fibonacci of 0.
Okay.
So with the Fibonacci of 2, the one in the, I don't know whether it's the soldier
green color,
light green also.
Okay.
Yeah. How do you arrive at that number?
Okay, so this is how we arrived at. You see that when we said we are finding Fibonacci of 3, which the formula we'll use will be n minus 1 plus n minus 2, where n is equal to 3. Do you get that one? Now, when we do that, we'll have 3 minus 1 plus 3 minus 2. 3 minus 1 will give you 2, which will then 3 minus 2 will give us 1. So the answer, the computation there will now be Fibonacci of 2 plus Fibonacci of 1. Do you get me?
Yeah.
Fibonacci of 1 is already 1, so we can't proceed. We have Fibonacci of 2 here. We can't leave it there, so we need to proceed to find Fibonacci of 2.
Okay. So the Fibonacci of 1 ends there.
Yes, because that one, Fibonacci of 1 is already 1. There's no calculation for that again.
Charlie, Takuk, you are good, oh. So,
Okay, so Christian, highlight Fibonacci of F, Fibonacci of 1, and then Fibonacci of 0 to change the answers to red. The colors to red, rather. No, the last one.
Yeah. Okay.
Oh, okay. So those ones we are not proceeding again.
Okay.
Change it to red. No, change it to the red, like the one you did for the Fibonacci of 1.
Okay.
Yes. Okay. Now, for us to now get our final answer for Fibonacci of 3, we have to pick those in red. Fibonacci of 1 plus Fibonacci of 1 plus Fibonacci of 0. You get me?
Yes, here will be 1.
Come again,
Yes.
please.
Yeah.
The first one.
So it ends there.
So we pick the first Fibonacci of 1,
And then 0.
where we had Fibonacci of 2 plus Fibonacci of 1.
Then we'll go and add the one at the top.
Yes, the other one. But if the reason why, Christian, wait, if it is an exam, there will be mark allocated to the calculation.
There's the steps.
Yeah, so you have to do it that, therefore, Fibonacci of 3 is equal to Fibonacci of 1 plus Fibonacci of 1 plus Fibonacci of 0.
So, okay. So let's say, therefore, what is it? Therefore, you can't get therefore in calculation.
So just even you can use this, just say Fibonacci of 3 is equal to
Okay, so it's equal to
so f of 1.
F1.
Yes.
Okay.
Plus F0 plus F1. Then plus the F1.
Therefore, this is the final answer.
We are still arriving at it. So clear the other ones. So when you put it this way, you know that f of 1 is 1. So we now have the answer to be equal to 1. F of 0 is 0 plus 0. F of 1 is 1. So we now have 1 plus 0 plus 1, which will give us 2.
0 plus 1. So f of 3 is equal to 2.
Exactly.
Oh, really? So
yes.
I want to ask the I've even forgotten the name. The f of 3.
Fibonacci.
Fibonacci 3 is equal to Fibonacci 1 plus Fibonacci f and then plus Fibonacci 1. It means that
you have to do the calculation before you can arrive at this.
Exactly. That is what I want to ask.
Yes.
The ones that we have put here, it means they are the ones we got in the red
Is
the
it
ones that are in
exactly?
the red.
Exactly.
Ah,
Exactly.
it means where the first one, the F, the Fibonacci one, the first one at the top of the
Yes.
green figure.
Yes, which is
That is
red.
the first one.
Yes.
Which is the red. That is the first one. And
Yes.
then the second one is the F Fibonacci 0.
Yes.
And then the
I
third
know.
is the F Fibonacci
He
1 again.
he could have also written it as F plus Fibonacci 1 plus Fibonacci 1 plus Fibonacci 0. But it's addition, so it doesn't matter.
Yeah. That is
Uh-huh.
exactly what I want to. So
Yeah.
it means that where we get Fibonacci 1 means that should be the concluding. It should be part of the concluding answers to what we are
So
finding.
maybe that's the top, on top of the F2 green. If the first one, which is Fibonacci 2, was also 0 or 1, we would have ended there, wouldn't have proceeded.
Okay.
Maybe if we got to that stage and we had maybe Fibonacci 1 plus Fibonacci 1 or Fibonacci 0 plus Fibonacci 1, we didn't need to proceed again. We would have added those two to get our final answer. But because we have Fibonacci 2 here, we need to solve for Fibonacci 2 before we can now get the final answer for Fibonacci 3. Christian, I believe you're okay now.
With this, I'm okay. I'm okay.
Okay.
I'm okay with this. But when the lady was right there,
Clifford.
Yeah.
Clifford, why are they?
So you see,
Papa?
This is for the 3. So when you have a bigger number to find for, the more you keep getting Fibonacci of a number that is not 1 or 0, you need to keep proceeding. But make sure that anywhere you got to that you had Fibonacci 1 or Fibonacci 2 as a last answer, you take notice of that, so that at the end you add all that to get the Fibonacci of the main number given to you to find.
When you get to the Fibonacci 2, so already we know 0 and 1.
Yes.
That they are 1 and they are 0, right? Like Fibonacci 0 is 1. Sorry, is 0.
Yes.
0. Fibonacci 1 is also 1. Okay.
Yes.
Okay. Then.
Yes.
Okay. Charlie.
Mention the word.
Fibonacci.
Yeah.
Charlie is serious. Charlie, we do our making our find code give him.
I swear.
All right, that
Charlie,
is it.
But Clifford, you did well.
Yeah.
Clifford, it seems you are just playing with this course. So. It seems you already know everything beforehand.
Sure, I know what everything. But we are all struggling. But it's just that sometimes some of us we go extra miles. Me, I don't joke. I don't joke with self studies.
Oh, okay.
Okay,
that's good. We are only okay. We are 12 left here. It seems others are also enjoying this.
Very well.
Yes, I'm here. Yes, sir.
The time now is 10:29. Can we go a little further to 11 o'clock? Clifford.
Allah.
Take us back to the previous formulas. With this explanation, I'm good to go. If I have this understanding from the beginning, matter, I will even join the lectures. Seriously.
It shall be well.
Take us back. There are other formulas before this Fibonacci. Clifford can help us on it.
This is
which formula is that?
Oh, are there no other formulas aside this one?
We have close to.
Mel Mark.
This one
Someone is laughing
Mel
at you.
Mark, stop laughing. Mel Mark, stop laughing. Stop laughing.
Yes.
This one is for Fibonacci. There was one we did
Yes.
earlier. That is factorial something something.
Exactly.
And it seems
Mr. Eric, thank you.
they are all under one. Is it recursive?
Recursive.
Something. So
Yeah.
let's take it from the recursive and break it down up to.
Who told you I understood that one?
Oh.
Christian, do you have the formula with you? The code. I wanted to screenshot it, but I forgot.
No, I don't have it.
You see, it's just like the same mathematical way of finding the factorial of a number, but like the code is just explaining to us how the machine is being given the algorithm to be able to find the factorial of any number when the number is being given to it.
That is my problem. Even if you understand the formula, how to fuse it into the code, how to write it with the comments, that is where I have problem. This Fibonacci, for instance, I've understood it from the way you are presenting it. I've understood everything. But if I'm asked to use the code the way the said did it, I'm going to get confused.
Okay. I get it.
It's not you alone, no. We are also free here.
No, you see that one, no? With that one, maybe you want a machine to find the Fibonacci of a number, right?
Yeah.
Yes.
So maybe you have to tell it that you have to declare your this thing. If the number given is 1 or 0, then it should return that number. Is that okay?
Yeah.
But if it is not so, it should return that number. Else, it should use the formula n minus 1 plus n minus 2.
Okay.
So the reason why it falls under recursive, you see, when we're finding for Fibonacci of 3, you realize that at a point we have to go and use the n minus 1. So this one is a recursive formula like that. The n minus 1 plus is being used again along the line because we have found another number that we need to find the Fibonacci of it before we can get the final answer for the first number.
Okay. So we went to 2. That is for Fibonacci of 2.
So you see that that formula is recurring again.
Yes.
That is not the making of the user, but once it becomes necessary, it has to recur again.
Okay. Okay.
Someone says something. Clifford, I have sent the factorial code to you. Is it on WhatsApp?
Oh. Okay. The factorial.
Okay, someone sent me something on WhatsApp.
They sent you. Okay.
If n is less than -1, return 1. All right, so can I go on?
Okay, go on. Okay, send to me so that I'll put it on the screen.
Huh?
Go on.
You can send to me so that I'll put
Go
on
on, Clifford.
Send to
do what?
Send to me so that I'll put on the
Go
screen.
Go on.
I'm not getting you.
I said send to me so that I'll put on the screen.
Oh, okay.
Yeah.
Mr. Movie major extra classes can why.
Hey Mel, you're here.
Yeah, maybe I'm in a major extra classes can why.
I've not
Extra
heard from
classes,
you
no.
since you started, though.
You've not heard from me.
Yeah, at all.
I mean, I respond with emojis. So.
Christian.
Yeah, I've seen it. I've insected
Yeah,
it.
so you put it on and let me explain it. It's a simple thing.
Okay. I think we're okay.
Yeah. So Michael. Hello?
Yeah.
All right. So with this one, you see
I'm
that
here.
the declaration is int fact integer 6. So we are finding this one, the code is written to find the this thing, factorial 6. Is that okay?
Yes, sir.
All right. So they are saying that if n is less than the inside there is less than or equal to 1. The second one didn't come well. The equal sign. No? Hello.
Okay. So
if n is less than or equal to 1, then return 1 because the factorial of 1 is 1. Is not true?
Yes.
Why it will be 1. Else return n factorial. And inside, no, I think the man made a mistake. It's supposed to be n minus 1. Hello?
Yeah.
I'm sure he didn't take note of that.
Okay.
Is that okay?
Sure.
So look at this. So if the n is equal to less than or equal to 1, then return 1. So if you find the factorial of 1, then the answer will be what? You multiply that number by 1. So what do we have here? 6, right?
Yeah, 6. Yeah.
So 6 times 1 will give us what? 6. Hello?
6. Hello, 6 what?
We are finding the factorial of 6. Is that okay?
Yes.
Yeah.
Now, the question is that, so we are going to look at the numbers we'll be multiplying 6 by, like the normal mathematics. When we are doing with the normal mathematics, is 6 times 5 times 4 down to 1, right?
Yes.
So this one is telling the machine how to do the calculations downwards. So we know 6 is already constant. So you put the 6 down.
Okay.
So the first one, how do we get the 6? This number, we said if n is less than or equal to 1, then return 1. So it means we are multiplying 6 by 1. That is how we have 6 as the first number. Are you okay?
Yeah.
Continuing. Else,
Michael, you're not okay.
n. Hello.
Let's start again. He said the thing is n is less than.
Present n is a variable whose value is unknown. Is that okay?
Yes. So
all right.
That is for n.
Yes. So the code says that if n is less than or equal to 1, the operation should return 1. Is that okay?
Yes.
Now, which number are we finding this factorial? It's 6, right?
Yeah, we are finding 6.
Okay, so we'll multiply that 6 by 1. We'll get 6. That's why 6 comes first.
Okay.
Do you get what my point?
Yeah.
Okay. Now it says that else return n times n multiply the factorial of n. So inside the bracket here, that negative one you are seeing is n minus 1. Christian, let me send you something for you to display that one rather.
Okay.
I think it will make it I've kept it in a code form so that it will be easily understood.
Okay, good.
Yeah.
Good.
This is a bit confusing.
Remember you extra classes.
Mark, take your time.
Well, because I was hearing you, I feel it's now confusing.
Break time, please.
Hey,
Morgan, take your time.
Geometries and then
Hey, break time, will say.
More break.
Say Ben,
Yeah, break.
Say Christian, I'm say break time.
Break time, please.
Say Christian, the action is screen.
Change lesson.
Please.
All right, Christian, I've sent the code to you. So it's the same code. So you rather display that one?
Okay.
Fibonacci. Hey.
Fibonacci.
As a Italian shoe brand.
I say over there.
Now, madam, no, or no bit me a chat na simple na. Or my branch any breast.
The thing is being recorded.
We are recording.
I said, mercy.
Oh, but Mr. Derry, the man, you know that you know.
He knows. But I was say, madam,
You know
madam, or simplify BBM and easy. Oh,
so
no,
that's a different. There's a difference between content and then American.
Oh.
Yeah.
Seniors, it's like even the teaching that we have.
Seniors.
Yeah.
Mm-hmm. Yes.
So more you know more from my
More than
you can say VPN yes no me. Yeah, from where you
VPN for only how
Christian.
Yes.
This is exactly what is supposed to be in the slide.
Okay.
So the declaration here, we that one we are finding for the factorial of 6. We are writing an algorithm for the computer to find the factorial of 6. Is that okay?
Yes.
Now it's saying that if n is less than or equal to 1, it should return what? 1. Else it should return n multiplied by factorial of n minus what? 1.
Okay.
Is that okay?
Okay.
Now let's make this the n minus 1. Inside there we are referring to 6 minus 1. Is that okay?
Okay, so let's this one, the return n times the factorial into bracket n minus 1.
Yes.
Let's interpret it here.
Okay.
So it will be 6 times, right?
Yes.
The factorial will be what?
The factorial is
5,
how to
right?
write it. Factorial is an exclamation mark in front of the number.
Okay, so let me write facts. Sorry.
Just put exclamation mark there.
Okay.
Maybe in the brackets. No, factorial of okay, you want to do factorial of brackets open n minus 1.
Yes.
You see, if you want to put it that way, you end up having a very long distance. But once this is a recursive code, is that okay?
Yeah.
So take note of that. Whatever value at the end of the day, to compare the final answer to the if statement there. Is the value lesser than or equal to 1? If no, then it goes back, it continues again. So here, our first value is 6. Now, when we subtract, what is it? 1 from 6, we have n minus 1. What will we get?
We get
5. Okay, so 6 times 5. Is 5 less than or equal to 1?
Okay, so this what is going to happen?
Yes.
So it will be into brackets 6
times. So go on. Clear. So remove the factorial there.
From there, yes. That is what we have to do.
6 minus 1, brackets close. Now 6 minus 1 will give us 5, right?
Exactly. So
is 5 less than or equal to 1? No.
Okay, then we return.
We return again. So n here now becomes 5. So time is brackets open 5 minus 1.
Okay, understand. So this is how it's going to be like.
Yes, so times again.
I'm coming.
Okay.
Times. Oh, sorry.
Mr. Kruja, Koyebia.
Let me put times like this.
Mark.
No, major classes.
No, Christian.
Yeah.
I think the way you were going
not
first
making sure
will
what
help
you are saying.
to understand better. So let's finish with that one.
Okay, so 6 times. So it should be 6 times.
No, you use the first line, the one you started 6 asterisk brackets open 6 minus 1.
Okay.
So you do plus multiplication there too, the asterisk sign. Okay, brackets open. Now 6 minus 1 will give us 5. So our end value becomes 5.
Okay.
So we now have 5 minus 1 in the brackets.
Okay.
Brackets close. 5 minus 1 will give us 4. We compare it to the expression in the if statement. Is 4 greater than or equal, less than or equal to 1? The answer is no. So we continue. Okay. Then time is 4 minus 1 will give us 3. We compare it. Is 3 less than or equal to 1? The answer is no. So we continue. 3 minus 1. Where 3 minus 1 will give us 2. Our 2 n becomes 2. Is 2 less than or equal to 1? No. Then we proceed. We now have what? 2 minus 1. Now our answer there will be 1. Is 1 less than or equal to 1? Then yes. Then we end the expression there.
So the expression will end at
we have 1 times 1 times 1 times brackets open. No, that's where you end, because 2 minus 1 will give us 1. We don't proceed.
I don't proceed. That is
Yes.
it.
So now when you come here, you now have 6 times 6 minus 1 will give us 5. Times 5 minus 1 will give us 4. Times 4 minus 1 will give us 3. So you end up having 6 times 5 times 4 times 3 times 2 times 1. That's
No, the 6 is not part.
The 6 is part. It starts from the 6.
Are you sure?
We multiply
Yes.
all the numbers.
Okay.
It starts from the 6. So we have 6 times 5, which is the 6 minus 1 will give us 5. Times 5 minus 1 will give us 4.
4. 6 times 3. 6 times.
Times 4 minus 1 will give us 3. Times 3 minus 1 will give us 2.
So,
yes, sir.
You repeated 4 twice in the first calculation.
Yeah. 4 minus 1, 4 minus 1. I just saw that.
You repeated 4 twice.
Okay.
Then time is 1, which is the 2 minus 1. The down one.
I just want to put them under.
Okay, so that there'll be space.
Yes.
Each of them should fall under where we are doing the subtraction from.
Exactly.
All right.
And then one.
Then we'll now have times. Good.
So this will be 1, right?
Yes.
1.
So you see that we end up getting the mathematical way of finding the factorial of 6.
Okay.
So this is how the code algorithm helps the computer to find the factorial of a number.
Okay. Mr. Blitz, are you okay?
So please,
yes,
I'm okay.
So when I get this, that's all.
It ends here.
Yes, it ends there. So depending on the number you are finding, if you are finding 5, it follows the same pattern. If you are finding factorial of 7, it follows the same pattern.
So, Clifford.
Yes.
The format of the question you have here, is this the same format the question will come in the exam?
Clifford.
Yes.
Clifford.
Yes.
Please, I learned you just, you started and then you stopped. I don't know if you have past question
on this one so that we use that one to, as an example so that we solve it.
Oh,
I don't know
no,
if you get what I'm trying
John
to say.
Edu.
Yes, sir.
John Edu, you are over jumping.
No, what I'm
Hold
saying
on,
is that
hold on.
no, listen, no, wait. What I'm saying is that
Why
you see,
go straight
one
to
of us
exam?
asked whether
When we are yet we even do our first quiz.
oh no, you don't get what I'm trying to say. What I'm saying is that you see, there is an example that we are solving, and we want to have a look at the nature of the question.
But
I'm not saying that.
let's focus on this one first.
Oh, okay, that's fine. Because me, I wanted to know the nature so that when you look at the nature,
Don't
you
worry.
know that this is how you do the procedure to solve. That's all.
Don't worry. Let's ask about this first and have maybe one deeper understanding, and then we move to the Clifford.
Yes.
Clifford, I was asking that the format that is appearing on the screen right now, is it the same format the question would take in the exam?
Oh no,
So
they may ask you
if it
to
is
write
going to be the same
a simple
format,
algorithm
assuming
for finding the factorial of a number. Hello.
Oh, okay. So assuming
maybe I started under a tree.
Assuming the question takes this format,
Assuming
and
what?
then the if into bracket n is less than
No. You see, hello. Hello.
3, and then we have to return.
Your number is breaking, so your line is breaking rather. So
Are you standing under a tree?
I am listening, Clifford. I'm hearing
your
you.
line was breaking, so we didn't get your question clearly.
I was asking that. Assuming, I am relating my question to the base case. The base case. I am asking that if then 1 in the bracket is changed to 3 or 4, and then we are to return it to the same number. And we have to return it to the same number. It means we are using the same formula as the n multiplied by the factorial all into bracket n minus the number.
Yes. You see, this one, it is made in such a, you see that when you look at the...
That is what I'm asking. Do you get me now?
No.
So imagine the 1 is changed to 2. That it means that...
Yes, exactly.
It will end at the 3. When it gets to where the final answer is compared to, and it's less than or equal to 3, it ends there. It doesn't proceed again.
And that is what I'm asking that. Assuming that number, then the 1 is changed to 3. Let's say the 1 is changed to 3. And then we are taking the same formula, Abi.
Yes. So it means
we are
end at 3. We will not proceed
formula.
up to the
Is
1. Yes. Continue.
Exactly. That is what I'm asking.
Yes.
Yeah, that
you
is
see,
what I'm asking.
What you should understand is that writing this algorithm, you mathematically you should know the formula for or how to find the factorial of a number before you can write this algorithm for the computer to do the calculation for you.
All right.
So
do you get what I'm saying?
The fact
so like basically, hey, let me come in a little. So but like basically, I don't think it's like for me, I don't maybe I stand to be corrected. I don't think it's like we are going to do this breakdown or formula thing.
No.
This will tell you that right and maybe an algorithm to maybe how to calculate a factorial of whatever. So
exactly that is how. So what we are seeing here, you may be asked to write that,
but not this calculation thing. But at least having the calculation behind your mind.
Yes.
That is how to calculate factorial of this. It helps you with your coding. But I don't think it's going to come up with this because the calculation will be done by the computer. You are not supposed to do this calculation of 6 asterisk whatever.
So you are providing the algorithm.
You are providing the algorithm, and then the computer understand how to calculate factorial of this.
Hello, Clifford.
Michael, you get this now.
Want you to explain what is here
Uh-huh. So here,
normal English.
hello.
What is here? This
Yeah.
is an integer,
Yes.
which is a variable.
Yes.
And the variable has been given a name, factorial.
Yes.
Like, let's imagine the integer is age.
Listen, this one tells you about the data type.
Yeah.
Good.
Now,
Explain it that way.
yes. Now the factorial, we are finding the factorial of an integer what? N.
Yeah.
So when you look at the slide, the integer there is 6.
6.
But this one is a general code N. So N could be any number.
Yeah.
So with this code, you can use this code algorithm to find the factorial of any number that the user inputs.
Yeah.
Do you get it?
Yes.
But when you put a fixed number there, it means you are writing the algorithm to find the factorial of only that number.
Yeah.
Okay.
Okay.
So let's imagine we put in place of n here, we put 4.
No. So if you are putting 4 here, so it means the first one where you are declaring the data type, you have to make sure the value, the n there, this n that is going through all is from the fact that the integer that is being defined there is n, which is a variable. We don't know the value of it.
Okay.
So you can't just come and put 4 here because this n is gotten from the first statement.
That is 8 5 to brackets. Okay, the n here.
Yeah, so that is how we have n here. So they are saying if that integer is less than or
So
equal to 1, then you should return 1. Else, you use this formula.
So imagine the here is 4.
Yes, yes.
Imagine it is 4.
Yes.
How are we going to compute it? Let's try it this way.
Okay, so if this one is 4, it means we are finding the factorial of what? 4.
4. Okay,
now,
so
the
4.
if one is a base case where the comparison is done.
If
you don't put 4 here.
Okay.
You get what I'm saying?
Okay.
That one is the base case where the comparison is done. So it means if we are working for 4 factorial, our first number will definitely be 4. Is that okay? Then we look, is 4 greater than, less than or equal to 1? No. Else, then we run the else. This is an if-else statement.
Okay. Okay.
So if 4 is not equal, less than or equal to 1, we proceed, then use the else. We run the else code. So we'll have n minus 1. 4 minus 1 will give us what?
Okay, 3.
So the n, which is 4 already, times what? 3. We compare 3 to the if statement. Is 3 less than or equal to 1? No. Then we proceed. You get it?
Let me come in here. It means we are going to start the whole thing from 4 here.
Exactly.
We are going to start from 4 here.
Exactly.
Okay. Okay. So imagine the 4, it will be written at the top here as what we have.
Like that wouldn't be also like writing 4 means that you are just limited. You are limiting.
You are
yourself
limiting it.
to-
You can't use that algorithm to find the factorial of any other different number.
Yeah, as apart from 4.
So this one that is in the slide like this is just
Go
to
back
find
again.
the algorithm.
Christian, go back again. Go back again. If you put the n to be 4, you are limiting yourself to find the how do you call it? The
factorial of 4.
4. But immediately make it n. Take note there, like n is captured in the factorial formula.
See, the reason why I said 4, when you watch here, you can see that the first statement here, that is what they have given, that we should find n with the 6. And 8
So,
is
6. Christian.
Yes.
There's nothing wrong with it. But what I'm saying is that this particular algorithm cannot be used to find the factorial of any other number apart from the factorial of the integer 6.
Yes.
Okay, yeah. Apart from the integer
So
6.
when you are writing it for future use, that anybody can use whatever program you are writing. Yes,
Okay.
so that I can just input just like the calculators we use.
Yeah.
The calculators we
any
use,
number
when they were
that will
programming
come
it,
into-
yes. The calculator, the scientific calculator we use, when they were programming it, maybe how to find the factorial of a number, it's on the calculator where you can just use a factorial to find the factorial of a number. So you can just input any number and the calculator will be able
the
to
calculator will
return the
give you the
factorial of
answer,
that.
but they are not
Yes.
limiting you. They didn't
Because
they are
when
not
they were
limiting you.
writing the code, they kept a variable there, not a constant or
Yeah,
just
it's
not a
variable.
constant integer.
Yeah.
Okay.
So they made room for the user to be able to input any other number, and the
Then it will give you the
computer will be able
results.
to give you the factorial of that number.
Yeah.
Okay. Okay.
So for me, as I said, it's like understanding the factorial formula and then knowing
Yes.
how to fit to algorithm. But like the computation will be done by the computer, not you, the user.
Okay. Okay.
You understand? It's about knowing how to state how do you call it? Use the formula in your algorithm. Do you understand? But the issue is if you also don't understand the concept, be it factorial, be it algorithm, how do you call it? Any of these math concepts, if you also don't know the formulas, it will be hard for you to create it corresponding algorithm.
Exactly. Exactly. Yeah.
Clifford, please, if I do understand the whole thing, looking at what we have on the screen, this is the kernel.
Yes.
Yeah.
So if they say you have to find the factorial of maybe a certain number, that is maybe 7.
Yes.
Right. So
Yes.
the 7 will not be in place of where we have the n, but rather where we have the 1 rather.
Int.
Well, the first line, that is where the 7. You see, when you input the 7, where you have int n, the n will become 7. That is at that point. But where we have the if, you don't change that n there.
Okay.
That is what I'm talking about.
That one is the base case. It's like it is a rule that whenever you do your computation, it compares the answer to that particular statement. If it doesn't, if it is not true, it proceeds to the next one.
Yeah.
Okay. Please, so if open bracket n is less than or equal to 1.
Yes.
So that one would change to the 7 I'm talking about, right?
Yeah. No, that's it.
No, the one will not change to 7. Listen, when you are finding the factorial of a number,
the n will change to 7.
Let me tell you where the 1 is coming from. When you are finding the factorial of a number, you start from that number, multiplying by the numbers that are lesser than it, so the number 1, right? So maybe let's say 3 factorial, we have 3 times 2 times 1. You can't proceed to 0. You can't say times 0 because everything will become 0.
Yeah.
Right.
So this one there is kept there because the person is bearing in mind the way we calculate mathematically the factorial of a number. 1 is the least in finding the factorial of any number.
Okay, so sorry for interruption. So if I do understand, the 1 over there is just is the last boundary. I mean the
result,
last
exactly. So when it gets to that boundary, it shouldn't proceed. It should terminate from that point, and the final answer will be given to you.
Yeah.
Okay. Then I do understand.
It means it's not go to the else again.
Yes, it will not go to it because that comparison will be true.
Yeah.
So that's why when we had 2 minus 1 will give us the answer 1. Then it will come and do the comparison. It's n 1 less than or equal to 1. Then it's true.
Yeah.
So it doesn't move to the else. It doesn't run the else code again. It terminates from there.
Yeah.
You get it?
Yeah, I get it.
Okay.
Yeah. Michael, you're trying.
The way
I'm
the
moment number number 2, you know. So now what you're okay.
Oh, I'm following.
All right.
They're still recording.
Are they recording?
Yeah.
Yeah, they are still recording. The recording sign is still there.
Hey, then, bro, let me go off.
Oh, okay, don't worry.
So the last person mute.
Clifford,
Yes.
why are you going off? Don't go off. We are just teaching. So
Are we not done? I think we are done.
No, we are not done.
I think what in the slide, no, when he uploaded, he didn't go check it well. He didn't see the mistakes well.
Okay.
Understood. Clifford, why are there? Why?
Matthew.
Why?
No, Shrai,
May God bless you bountifully.
Bless you too.
Melmark, Sean.
I'm waiting for your
sister, the Afro pop artist.
Yeah, someone called.
My sister.
I mean, Takrady.
Oh, okay.
Michael, which of my sisters?
They are Sean, the artist, a celebrity. Is he your sister?
Who?
I'm asking Melmark. Melmark.
Is that if it's my words?
Is she your sister?
If it's my sister, I wouldn't be doing Swiss show.
What should?
What are you trying to say?
I'll be studio
I mean
manager.
your name. I'm relating my question to your name.
That's what I'm saying. Sir. If you my sister, I'll be studio manager.
Or where? You still need computing skills. You still need IT skills to manage the studio.
Oh yeah, that one there.
So you are the right place.
Time. It's like it takes time. Also, those who did computer science, they are doing it for like 4 years, okay? And it's like
exactly.
There's that ample time to challenge diversity.
You see, one thing we need to understand about Michael.
Yeah, I'm here.
When it comes to the field of computer science, if you are not somebody who likes doing personal learning and self-learn, trust me, you can never be good.
Forget it.
Exactly.
Because
you have the point there.
Day in, day out, new things evolve.
Now, if you even take aside the day in, day out, anybody who is teaching you a programming and all those things, there are AIs they will never talk about it. You can only tap it to different people.
Because they are limited to what they are supposed to teach you.
Yes.
And if he has to go back to certain basics which we are not included in the model, he will end up wasting his time and he wouldn't finish
the topic
what he's supposed to finish. So you may feel like he's not explaining to your understanding, but he's also on him because he needs to also finish what he's supposed to teach you. And at your level, you see, the requirement is that you are supposed to have some background.
Yeah.
So they assume that way, and then as they are teaching, they teach according to what the model says.
Yeah.
So if he's going back to some introductions and all that, at the end of the day, he will not teach what he's supposed to teach.
Yeah. But at the end of the day, we should ask ourselves, like, at the end of the day, after finishing the course, the question you should ask yourself is like, will you be able to code?
Exactly.
You can't. Because you have to do them C++, Python lessons on your own.
Yeah.
But it is assumed that like, after this course, you are an IT, whatever, blah, blah. But at the end of the day, you can't even code. So these C++, Python, and whatever,
the C++, I think we will definitely do it in a particular semester.
Okay, like, but even that
introduction to programming like this, the first block, they started C++ was introduced in the introduction to programming. But I think along the line, they realized that no, they should just teach the generic programming. Then when we have the basics, they can now bring in the C++. So that will be learning it as a programming language, a full course programming language for that semester.
Where you can be able to use it to create.
This one is just the basic one.
Yes, because I remember the first block, the one who was teaching, he made us download C++, and we were writing some codes alongside with him. So I'm sure one of the semesters will definitely do that.
No, that's what I was expecting. So,
Edu, you are at a party. Edu, you are at a party.
Not at the party, please. I beg, I'm not at the party.
Oh, I'm not sure C++, then now will be interesting.
Yeah, they'll teach. It's part of the program.
So then now will be interesting.
Like that thing has become theoretical for me.
No, this one is generic programming. They just want to get the basic concepts of programming across all the programming languages. The things that no matter the programming language you are using, you need to know.
Yeah. I mean, say you buy and I know more code in on American.
That's one thing people are not getting.
That was what we
That is how they started. That's how they. That's how they started. But you see, learning is progressive. Along the line, they realized that maybe that approach was not helping.
Yeah.
So let's break it down, because they would have combined what we are learning together with the programming language. You see that how packed it was going to be.
Yeah.
But when they teach you the basics, you get to understand the basics, and then they bring the programming language. You build on that to focus more on the language itself.
Yeah.
You just have to just psych your mind to at least always go through things yourself again.
Maybe them. I was like psych to say be math. The night I never knew to be like I'll use math. It was that way. But
So you see, some of the things too, as she was teaching like this. If you are someone who doesn't know in mathematically how to find the factorial of a number, you expect the lecturer to come and teach you how to find the factorial of a number before he now explains the code to you.
Yeah.
You
but
see where
this factorial thing, it was in the computing one. It was
mathematics for
inside.
computing. It was there.
Yes, the factorial was there. Just that we didn't get there. And even some came in the exam.
Just that the lesson was reading. Like sometimes they will read it to you. Math, we were solving math, reading math. Like
it even came in the exam.
Yeah, it came 10 marks.
So Clifford, I want to ask this. So please, in your first listed, were you offering maths, ICT, or it was ICT still communication design?
First, it was ICT and maths, and ICT and graphic design.
So I'm asking yours, which one did you choose?
I was doing the graphic design.
Oh, okay.
Later, they changed it to communication design.
Yeah, I mean the math which I come and see what is come and see what is happening in my class.
Proving of concepts and formulas.
Hey, who is proving formula?
They are not using them, they are proving them.
We are Einstein.
What's it?
I don't know Einstein.
That's how math is. So. You know, they build upon you learn the formulas, you use them. As you progress, you need to understand how those formulas work, how those formulas are
roughly 1.5 years where the intimate finance our math concept to you.
Oh no, but even SHS, I think this quadratic formula, there's a way of proving it.
Sure.
How the formula is, so that one is very.
You know, quite time. We'll bring time amount on why self tuition and
yeah.
So the even
the time. Look at all these courses you are reading. What time are you also going to get to do all those?
You see, the thing is that
one thing is that you see the 3 hours or the 4 hours is too long. For me, if they will do it maybe 2 hours, then we will continue as some other day for 2 hours. That one I'm
don't complete you.
Then you can't finish because they are.
No, what I'm doing is that let me learn. What I'm saying is that you see the thing is a whole 4 hours show. And as they are doing it along that line, we'll be getting tired and the rest, so the attention will be going. What I'm saying is that so that 4 hours, why don't they divide into 2? So maybe one particular day we will do the 2 hours. Then another day we have the another 2 hours. Then you continue from that in that order. Well,
so imagine this block. Let me come. This block alone, we have 5 courses. So it means we have to in a week. We need to have 5 different lectures. That's what we are trying to say. How many days do we have in a week?
So
and they also consider the fact that we are teachers, so we work in the weekdays.
Sure. That one
so they are taking into consideration all those factors.
I do understand them. That's why I'm saying that for me, if they could have done it that way, like maybe in the evening you do 2 hours, you go, you sleep, and then there's some other you come and do another 2 hours.
You see, one thing you need to also understand is that those who are teaching us, some of them are also teaching regular students on campus.
So what we will touch now is that now, which is my C was 5, you can see that I moved to 6.
What are you sharing?
Christian, we can't see anything. No.
And then it moved.
What are you sharing?
Christian.
Yes,
there's nothing. You're not sharing anything.
I'm coming. I'll share it to you.
Christian, anya pobiana. Christian, anya pobiana.
Ron Edu. Ron Edu.
Senior.
Why did you add your index number to your name?
Charlie, it was one of our lecturers, our math lecturer, said we should add the index number attached to our name. Initially, it was not like that. He said we should do it that way so that it can. I don't know whether it will be going to award marks or whatever. Based on, I don't know. That is why I added it, and it's still there. It got to a certain point. Is that he said before you enter the class, add your index number. That's why it's there. I don't know if you realize. At the beginning, it was
math class.
Yeah, it's math class. That's what I'm saying.
Also, mathematics for computing.
Or would there be a formula? So, like,
if not, I'll take you off.
Hey, so
We did offer.
We're a friend. Learner identification formula.
Oh, Charlie. This one is the learner center that you are talking about. Learner center.
Christian, share your screen.
Share the link.
Oh, maybe Christian was talking to someone else.
I wasn't talking to someone else.
Oh,
I
okay.
was trying to share
the link
on VLC, but it seems it's not working.
Oh, okay.
I think this Google Meet app doesn't support that. Either the app is heavy for the app or something. I don't know. The VLC.
You have a video.
A video of last year's lectures.
Oh, okay. That's right. We are blessed.
Last year lectures on what we just did.
Oh, okay.
So I think
See, I started from 1.
So it's not talking about the quadratic time complex.
We start from what is here will also be.
If it's not showing, then can it be on our platform?
Okay.
I have to go off.
My other platform.
Okay.
I have to go off and attend to something.
All right.
I think I saw somebody saying you want to talk.
Christian, share the video completely on the screen, and then it will appear here.
Sure. So if you come to
Asana.
Good morning.
We can't hear you.
Yeah, good morning.
Morning. Michael, you said you'll be checking on me. I've been checking.
You are far from your microphone.
Hello. Hello.
Yeah, be talking now.
Hear me.
You see, these are the videos.
Play them.
And Asana, please, are you far from your hour? Are you using hands free? If you are using hands free, just take it off.
I'm not using it, but I'm suffering from cold.
Okay. So can we hear you now?
Yeah, please, can you hear me?
Please talk.
Yeah, we can hear you.
I was directing my question to Michael, but it's not active online now. But
I'm here.
Let me make a general.
I'm here.
Not be checking on me. Hello.
Asana. Yeah, I'm listening.
You said you not checking on me.
Oh, really?
Yes. Since the end of time, you've not been asking about me. Go to bed, though.
Hey. Really?
Yeah. After our last paper that Sunday. So I've not been. Let me make a general comment. I've not been following the class for some time now because of my condition. So please,
Asana.
Yes.
I've seen the record.
Have you
I've seen the recording sign there. So I don't know if you can chat him behind the scene or you call him personally.
Okay. Then
Hey, Asana, I don't even have your number.
Okay, I will send you a hi.
Okay, hi me. Let me see.
Okay. Thank you very much. But my reason is that okay, let's do it without the recording. Okay, thank you very much.
You're welcome. So Christian, can you share us the video? Play the video.
Okay. And the video, when I play, the DLC does not support, sorry, the Google Meet does not support DLC.
Now try now.
I should try what?
Try playing it now.
Okay, you see what happened. I've double click it, or probably let me open it or play it. See, it's not showing, but it's playing now. It's now playing.
It's playing at your end.
Yes, but it's not
presenting this time complexity. We look at the asymptotic location and checking the behavior of the algorithm when the input size increases will be our focus. That is what we do.
Yes.
Close the video. Close the video. Close the what's
the window.
Name?
You close the window.
Yeah. Close the first video.
Okay.
Close the first video. Let the video player only show on the screen.
Okay. But when you go to you don't understand what I'm saying.
Or you can even hide it. Minimize it.
I've minimized it.
The first video and allow the.
Is it showing? No.
No.
You've not minimized it.
I've minimized it.
Okay, minimize it and let's see.
I've done it.
Charlie is still not showing. How do you call it? The gig, the size.
The size.
The size is what?
The size would be 118 megabytes. You see the size here. Have you seen?
Okay, I've seen it. Yeah, I've seen
it.
118 MB in and out.
So you can imagine. And we have this is for 5. This is lecture 5. Lecture 6. That is unit 6, unit 5 and 6.
And these people, they were very lucky. We were able to go to 5 and 6. And here we are. All right, seniors.
Okay, so we should go prepare for the next lecture.
Charlie,
yeah.
I'm going.
Okay.
Charlie,
I'm also leaving.
Thank you for the time.
Okay, you're welcome, sir.
Charlie, you guys are great, all of you. See you.